Also, doctors, we are running with Diwali offer. So I'm just sharing my screen for now. You can also take part in the Diwali offers as well, and you can avail exclusive discounts. So as you can see here, I hope my screen is visible to everyone. So we have exclusive Diwali offers which are going on, where you can buy products and you get exclusive giveaways and freebies as at the discounted prices. And also these are the exclusive prizes and giveaways you get from Colteen. So you can avail these Diwali offers. These are valid till 5th of November. So you can contact your nearest salesperson or you can connect with us, anyone from the team. We will help you with the offers to avail these offers as well. I'll share these offers on the WhatsApp group as well. Dr. Amneet, it is still not started. We're just waiting for the other participants to join. Once everyone joins, we will start with the session in just 2 to 3 minutes more. Good morning, everyone. Dr. Karthik, sir, we can start with the session.
Dr. Sneha, we can begin.
Yeah. Okay. So good morning, everyone. It gives me great pleasure to welcome everyone to today's webinar and a special welcome to our esteemed speaker, Dr. Karthik Shetty. Dr. Karthik has been a highly respected clinician and an academician known for his expertise and innovative approach in the field of dentistry. His commitment to advancing clinical excellence and sharing knowledge has inspired professionals across the country. We are truly honored to have him with us today to share his valuable insights and clinical experience. I'm sure this session will be an enriching learning opportunity for all of us. Thank you, Dr. Shetty, for taking time to be with us today. We look forward for an engaging and informative session ahead. So thank you so much for all the participants for joining this session. So Dr. Karthik has been our KOL and associated with Colteen since a long time, and he's been really friendly and really very, very approachable. We can approach him with all our concerns and doubts, and he's always happy to help us. So we'll just have a small CV for sir, and then we can start with sir's session. Dr. Karthik Shetty is the head of postgraduate research vertical and professor in the Department of Conservative Dentistry at Manipal College of Dental Sciences, Mangalore, and the director of Excellence Dental Healthcare Center, Mangalore. With over 18 years of experience, he specializes in retreatment and surgical endodontics, endodontic sealers, pain control and endodontics, and root canal anatomy. Dr. Shetty has received numerous awards, including the Best IDA Branch Secretary Award for the years 2013 and 2014, the Distinguished Researcher Award in the year 2022, and several accolades for scientific papers and poster presentations at national and international conferences. He is a fellow of the Indian Society of Oral Implantologists and an active member of professional bodies, including the Indian Dental Association, Indian Association of Conservative Dentists and Endodontists, and Indian Society of Prosthodontics, Restorative Dentistry, and Periodontics. So it is an extreme pleasure, sir, to have you with us today. And thank you so much for taking up the session and taking up the time to host this wonderful session today, sir. So we welcome you from Colteen and all the other participants as well.
Thank you, Dr. Sneha, for that wonderful introduction. I'd like to begin by welcoming all of you, all the participants, to today's session. Colteen has been very kind and generous in giving a lot of time. So when I saw the duration of the session, we have from 10 to 2, but I don't know if we'll be taking up that much time. But it is a fairly comprehensive presentation, what we have today. So I think you can get a cup of coffee and you can sit. It's a Sunday morning. So we will run you through all the aspects of how to deal with the fractured file, but we will also get to the genesis of the problem also, which is what exactly are we dealing with? What are NITI files? How have they developed, and how do we avoid fracture? Various aspects of this particular problem or quandary we will try to assess because we have the time available. At the outset, I'd like to thank Colteen India. It is a wonderful organization that I have been happy to be associated with. So uh, we recently, all the KOLs from India, we had this lovely trip to Alstatten in Switzerland, which is where the Colteen headquarters is, and we got to meet with the senior management of the company and also see the kind of extraordinary work that goes on in this company and where the products are generated, and I also got to see the R&D behind these products. I always held Colteen in very high esteem, but post this visit, my regard for the company has increased even more. They have a wonderful team working over there, as well as a great team here working in India, who I have been, associated with for the last 2 years. I'd like to, thank Mr. Farad Hassan, MD, Colteen India. He was along with us on this trip. He was leading from the front, showing us whatever the company had to offer and where everything was being created in Switzerland and in Germany. And a big part of the success of the visit that we just had. I'd like to thank Mr. Balachandra, who's the head of South India for Colteen India, a big shout out to Dr. Snehashree Pawar, who you just heard. She has been relentlessly working along with Dr. Darshana. She has been calling me from the last 2 or 3 months, trying to set up the date for this program. And even the topic of this program also, a large part of it had to do with our discussions. We were talking about what could be something which would be interesting, beneficial, and useful for the clinicians, and which we can throw some light on, and where also the competencies of Colteen will be shown, and will be highlighted. So we thought that dealing with fractured instruments, this is a big challenge that all of us clinicians face in our clinical practice, and it is something that we always dread. So we thought this may be a good topic to speak on. It's a challenging topic, so let's see what we can do with it. I'd like to thank Mr. Sanjay, who is the head of Colteen in Karnataka, and Mr. Shashi, who is the representative for Colteen here in our district of Dakshina Kannada and the city of Mangalore. Both of them are here today. They were here. Every time we have a webinar, they make sure that everything is going on schedule. So I thank them for all their help and all their support in putting this together. So with that said, we will move on to what we want to deal with today. And I thank you all one more time. Sunday morning, it's a free day, so I'm sure that all of you who have come here today, you are genuinely interested in upgrading your knowledge. So upgrade dentistry is what Colteen is trying to do, and they're doing it in a very sincere manner. And upgrading skills, upgrading knowledge, upgrading the type of equipment that we're using, that is what we are all here for today. And let us have a two-way discussion. This is going to be a very let us try to keep it as a very involved, mutually beneficial program. So I will have a lot of things that I have in my mind. I will discuss it with you, and later at the end of the program, if you have anything that you want to ask me, please go ahead. And post the program also, they will be making a WhatsApp group. Any doubts you have, you can always share on the WhatsApp group, and I'll see in what way we can best answer it. This presentation, just to give you a broad eagle's eye view of what we're going to be doing today, this will be an evidence-based presentation, because I believe that we need to work with an evidence-based protocol. We have this concept in any clinical fields. We feel that it works best in my hands. That is very, very true. In our clinical practice, we have our own tricks and tips, etc. But at the end of the day, what evidence does, or what literature does, or what documentation does, is actually it collates large amounts of data, and we are able to average out the success rates, and we are able to get in protocols which are repeatable. So whenever we train, it's always better that we train with an evidence-based process, and then of course the clinician can then go on and improve it. So there are two aspects to this. There is evidence-based clinical practice, and then there is our expert domain knowledge. Expert domain knowledge is what all of you, being expert clinicians, you will be doing in your own practices. But today we will be trying to also evaluate what evidence we have. So all information that I am sharing with you is going to be predominantly evidence based, and a small component of it also will be expert domain knowledge, which out of my clinical experience I will try to share with you what I feel has worked in my hands. We will have a visual component to this program, and we will have a lot of clinical cases. These will come towards the second half of the program, or the last third of the program. So we will load up the first half with some heavy duty data and theory, and we will complete it. Like the dessert section will be a few nice videos of some cases, some nice instruments which can potentially be used when we are going to be treating cases where there are fractured instruments. So what are all the tools which are available to us? All those things we will cover towards the fag end of the program. But
Doctor, sir, just sorry to interrupt. Your voice is a little not clear because the participants are mentioning in the chat. So just if you could increase the volume a little bit.
Is it better now? Is it clearer now?
Yeah, participants, I hope it is better now.
Just check if it is static or if it's the volume. If it's the volume, we can change it.
No, it's the volume.
It's the volume.
Yeah, volume.
Is it better now? Because if there is
yes, much better.
Better right now, no? Okay, done.
Yeah.
Okay, so we'll just move the screen a little bit closer. Okay. So the whole idea today is going to be that we want to learn something new. So at the end of every presentation which I try to give, I just try to see if it is possible to transfer at least one concept or one or two key concepts over to whoever is participating. They can take it over and they can translate it and use it in their practice. So if we can achieve this, I would feel that our time is well spent and the presentation is successful. So this will be the workflow for today's program. We will talk about the development of nickel titanium files. A large part of this presentation, the first part of it is going to be on the development of NiTi files. I did toy around with the idea and I felt that, should we cover this or not? But what you have to realize is that we always say prevention is the best cure. So fractured instruments, it is a iatrogenic problem. It is a clinician created problem which can be avoided if we are more careful. How can we be more careful? NiTi is a very unpredictable instrument. So sometimes just a general knowledge of nickel titanium, the type of files that we are using, that itself is going to go a long way in reducing the fractures that we have. For this, we need to understand a little bit about NiTi and a little bit about the type of files that we use or what we buy. Currently, there is a crop of instruments which are available in the market which are less expensive. So sometimes what we do is we make our choice based on cost. But there is data to this, there is evidence to support this, which has categorized this type of instrument into the newest, one more generation among nickel titanium instruments, which are instruments which are new, which are less expensive, but not really as well tested as the more expensive or the better files in the market. At the same time, they don't behave the way that normal NiTi should behave. Now, how should normal NiTi behave? This is what we will be covering in this part of the seminar. So, even though it is a bit theory heavy, this is the key part of the program, without which the second half of the program would be a little challenging to really understand, because some of the terms will start throwing around which we will cover in the first half will be useful for you in the second half. We will then try to understand the reasons for instrument fracture. We will try to figure out the methods to reduce instrument fracture. We will discuss management of instrument fracture and what are the options available for us. We always feel that when there is a presentation on file fractures, it's always going to be full of fancy videos of removing the file from the root canal. It's not that you have to get in there and try to remove every file from the root canal. That does not ensure success or failure. Success is what you want. Success is what will give you more confidence. It will give the patient more confidence in the procedure. It will improve your practice. So now, what is your choice for success? Should you retrieve it? Should you bypass it? Should you remove it? That is the choice that you have to make. Following which you can go about and you can try to retrieve it and use all those expert tools, techniques, etc. So this is what we'll be covering in that part of the session. We will also then discuss all the different tools which are available, for us, which we can procure to make our journey of retrieval of instruments better. We will discuss some protocols and some tricks in removing the instrument from the root canals. And finally, we'll close it off with a few cases where we can discuss how we have approached retrieval of instruments from different parts of the root canal and different techniques that we have used. So this will be the whole workflow for the presentation today. So what do we want to learn? What should be our learning outcome? Before every session we attend, we need to know what we want to learn. We will learn how to select nickel titanium files when we buy it. We will learn how to minimize fracturing files inside root canals. I do not say how to completely avoid it or how to prevent it, which is difficult, but we will learn to minimize. How to proceed in case of a file fracture. What do you do? How to identify specialized instruments used for removing these fractured files from root canals. How to learn different protocols of file retrievals. And finally, also I have added how to evaluate the difficulty of file retrieval. We should be able to know when we can do it, potentially when we can refer it, or whether to attempt or not. That is also something that I have attempted to do in this presentation. Let us see how it goes. Dr. Sneha, is it clear now? I hope it's a little audible.
Yes, sir. Perfectly fine now.
And also, as long as it's great. Anytime in between, please feel free to interject and let me know. If there's anything wrong with the audio or visual, that is the only way that I will know. Otherwise, this is the webinars are one-way communications. So let me know and
Yes,
we'll
sir.
take the corrective action.
Definitely, sir.
We will also,
Participants, I hope it is clear to everyone now. The volume and the voice is much better. Okay, sir. So you can continue.
yes, so Dr. Sneha will be there on the chat box continuously monitoring. So anything there is, you please put it out in chat and she will immediately let us know at this end. And we will also take maybe one
Yeah.
break somewhere
And
in
so just
between.
one more thing, participants, you can start sharing your questions in the chat box or in the Q&A box. You can, if there are any questions related to the topic, you can ask them. You can ask, sir. Yeah, thank you so much.
Yes. And we will be taking one break in between somewhere, so that the session doesn't become just too long for you to attend, maybe for about 5 minutes. We'll see how it goes because, to be honest, they've given me so much time. I did not even go to time this presentation. So let us see. So to begin with, the primary aim of root canal treatment, we all know. You have to just step back and you have to see what are we trying to do here. We are trying to treat apical periodontitis most of the time, and this involves disinfection of the root canal space and sealing of the root canal space. This is essentially what we are trying to do. I hope we are all on the same page here. We need to understand that the problem here, what we are dealing with in root canal treatment, is a biological problem. But of course, we tend to look at instruments and we expect them to do all the work for us. So that is more of a mechanical solution. What we are trying to do, please understand, it is a biological problem. So your solution also should be a biological one. This is an excellent article by Prasanna Nilakanta and team, which explains that root canal infections are biofilm mediated and microbial persistence is the most important factor for failure of root canal treatment. Don't look at that radiograph and assume that because it has been obturated to 0.5 millimeters from the apical end of the tooth or the radiographic apex, the case is going to be successful. It may not be the case because there are microbes over here which will have the last word. So what are we doing? We are doing biofilm removal using a chemo mechanical process, using specific instruments and disinfecting chemicals in the form of irrigants or intracanal medicaments. That is what we are trying to do. So the objectives of root canal irrigation is to dissolve vital or necrotic pulp tissue, disrupt endodontic biofilms, neutralize the endotoxins, and remove the smear layer. This is the whole picture. Now, where do root canal instruments come in? Root canal instruments, they provide us access to the entire root canal space so that we are able to achieve this biological goal. So shaping, it will precede cleaning. So you really require to do diligent shaping, the way that Schilder told us to do it, to make sure that your irrigants can get to every part of the canal and achieve the cleaning that you want to get. So coming to today's topic is the life cycle of a fractured instrument. As I told you, this is the way that we will be proceeding through this presentation. We will talk about the origin of the nickel titanium instrument, because without knowing the origin, we will not be able to assess the today or the now. We will look at the evolution of NITA instruments. Then we will move on to fractured files. We will talk about impact of the fractures on the outcomes of treatment. Does a fractured file really impact your treatment? Is it that you have fractured the file and your treatment has failed till you have removed the file from the canal? We will discuss about whether we should retrieve the instrument from the canal or should we just bypass it. It's easier to bypass it sometimes rather than retrieve it. And once you have bypassed it, should you proceed to retrieve it or not? We will talk about retrieval per se. We will talk about instrument retrieval protocols, the tools, and finally we will end with case discussions. So you know the workflow now, and we will pace it out as we go along. Now, the origin of nickel titanium instruments, the interesting part is there is a subcontinental side to this. I say subcontinental because the first nickel titanium file was made from a number 15 size orthodontic wire, and it was made by Harmeet Walia. I say subcontinental because he was born in Burma. Of course, he studied in India, and this led to the understanding that we had this metal which was very flexible and which was able to go into all sorts of curved canals. It would not get distorted, and it did not have the stiffness that your stainless steel files had. That was one thing. The second thing is, if you wanted to use an instrument which was rotary, which was going to be used in a rotary motor, you cannot use a stainless steel file in a rotating motor, because the stainless steel file, as you know, it is very stiff, and as the size keeps increasing, the stiffness keeps increasing. So it is not really very conducive to a rotary motion. But here was a metal, nickel titanium, which was able to be used inside a rotary motor because of its flexibility, and we could actually increase the sizes also. So you saw sizes with the basic NiTi files which were similar to your K files, 15, 20, 25, 30. Then you had rotary files coming in with tapers like 2, 4, 6, 8, 10%. This is all possible because of these properties of this material, which was your shape memory and your super elasticity. That article itself, by Harmeet Walia, this is, if you look at it in the 100 most cited articles in endodontics, this is still, if I remember, it is the 10th most cited article in endodontics. But then, of course, we have come a long way since then. There's been a lot of development in nickel titanium, and the instrument has, of course, evolved over a period of time. So how do we track the evolution? There are two very good, very significant articles, one by Haapasalo in 2013 and one by Ove Peters in 2022. So both of these articles, they're very similar, but Haapasalo tried to divide the development of nickel titanium instruments into 5 generations. And Peters at 2022 realized that, okay, there is some more improvement happening over here, which cannot be captured in the categorization given by Haapasalo. So he added a 6th and the 7th generation. So we will go through this. But again, one thing to remember here, a very interesting thing to remember is, see, if you take a generation of your family, you may be whichever generation of your family, you will not repeat in the next generation. But this does not happen in this system which has been given by Haapasalo. Here, the nickel titanium file may repeat in the 3rd generation and may again come back, and you may see it in the 5th generation. So probably a more relevant way or accurate way to call this development would be verticals. We have 7 verticals of development which take place with nickel titanium, and we will discuss all the 7 verticals as we go along. To start with, what are the improvements focused on? Essentially, with nickel titanium instruments, what do we want? We want increased flexibility, increased durability, and increased cutting ability. So all the development of nickel titanium has been taking place along these lines. So the flexibility has increased, the durability has increased, and cutting ability has increased. Now, to understand the increase in durability, you need to understand 2 key words which will keep repeating through this presentation. So let us try to touch upon it: cyclic fatigue and torsional resistance. So what is cyclic fatigue? Now, cyclic fatigue is whenever you put a rotary file inside a canal and it starts to rotate, inside a curved canal, when it rotates, the inner side of the curvature, the instrument is getting compressed, and the outer side of the curvature, it is getting stretched. So as this instrument rotates multiple times, at one point it will fail because it reaches its limit of cyclic fatigue. So the key thing when we talk about instrument fracture is that you need to know the instrument is going to fail at some point. Of course, with the development, this point has been put further up the life of the file, but it is going to fail. That is for sure. So when you see anybody who comes and markets an instrument to you and tells you that it will work for 10 teeth or 20 teeth or 30 teeth, it does not work like that. The instrument is going to fail based on NCF. What is NCF? It is number of cycles to failure. This is pretty much fixed in the life of the instrument. So please remember that the number of cycles that the instrument is undergoing inside a curved canal is more important rather than what is being told in terms of how many times you have used it on how many teeth or how many canals. So that is what cyclic fatigue means. What is torsional failure? Now, torsional failure is where the instrument which is rotating, the rotary instrument, we know the canals are narrower than the instrument. So obviously your instrument is going inside and it is widening the canal. You will of course, before using your rotary file, you will go in there and you will put a glide path to make it a little bit easier for your rotary file to rotate inside the canal. But since it is a metal, it has got a maximum torque value at which it is going to fail. So when your instrument locks into the apical part of the canal, the lower part of the instrument will stop rotating because it is now locked in. The upper part will continue rotating. The instrument will fail at a particular load of torque. Now this can be prevented by making sure that you have set the right torque value into the instrument in your gear reduction handpiece or into your endodontic motor. But the manufacturer has already given you the value, and the unit of this value will be in newtons. The manufacturer has told that this file can take so many newtons of torque. So please ensure that you understand your instrument very well, and whatever torque value which that manufacturer has given you, have a really good endodontic motor, in which all motors of course will have it, in which you can set the speed, you can set the torque value, and you use it the way the manufacturer has told you to use it. So with all these instruments, there is a learning curve, how you should use the instrument, the motion of using it. So make sure that that is programmed into it. This again will go a long way in mitigating failures or fractures of instruments within the canals. So like I said, these instruments, we have 7 verticals of development. So what happened in the first generation? We had nickel titanium coming in. So when nickel titanium came in, obviously we had increased tapers of instruments. This was introduced in 1990 and there were larger tapers. So till then we felt all instruments should be 2% taper. But then we saw 4, 6, 8, 10, 12% taper coming in, and the first design, the basic design of nickel titanium instruments had these things called as radial lands on them. So they took this tapered nickel titanium wire and then they put these 3 grooves into it. So when they put these 3 grooves into this nickel titanium wire, you got these radial lands, these 3 radial lands, which brought about a passive cutting, and you had these 3 grooves which will help in clearing out the debris. So this was the design of the initial nickel titanium file, what we saw with files such as Profile, etc. They also had a non-cutting tip for safety. So they were passive instruments. These instruments used to fracture a lot because the development of NITI itself was very nascent. Most of the instruments were made with an austenitic phase of nickel titanium. We will talk about it as we go along. I will make you understand what is austenitic and what is martensitic immediately later. So these files were rotated at a very slow speed, 250 RPM, because now we know what number of cycles to failure is. So the minute you rotate it faster, the NCF is going to be reached faster, the file is going to fracture much quicker. So the files were rotated at slightly slower speeds to reduce the chances of cyclic fatigue. One more thing done to mitigate it was, many instruments were given. So each kit would have about 8, maybe 10 rotary files in it, and the manufacturer would tell, please use the file just for a few seconds and then go to the next size file. So we had this large inventory of NITI files, many files which we had to use for a single case. But from there, today we have come to file systems which offer as low as a single file for instrumenting the whole canal. So you see how much technology has developed. So all of these were initially the issues with nickel titanium files, and there were these systems which were very popular then, such as Profile, Lightspeed, Quantec, Greater Taper, etc. Then we come to the second generation of nickel titanium files. Here there was an improvement in the design. So you saw the radial lands disappearing, you saw triangular cross sections coming in, and you had a positive rake angle, more aggressive cutting compared to the negative rake angles earlier. And also they realized that, okay, it is not necessary you have a single taper for the instrument. You can have multiple tapers in the same instrument. So you had instruments with multiple tapers coming in. ProTaper was popular in that series. It came out with shapers S1, S2, finishers F1, F2, F3. These were instruments that even I used to use it when I was doing my post-graduation. But these instruments were stiffer. They were quite aggressive. Because of the stiffness of these instruments and of the alloy, it would cause transportation of the canals. The stiffness was because these were made out of the austenitic alloy. The active design used to actually pull the file inside the canal. When you're using these instruments, I think all of you will know that sometimes the file will just get pulled along with you. So you have set your working length at say 19.5, you're rotating at 250 RPM, and the file just goes up to 21, 21.5, it just pulls you along. So this was called as the threading in effect or the screwing in effect, which is very common with this generation of files. Now the third vertical or the third generation of nickel titanium files, see, there were a lot of problems with fractures. So a lot of strategies to avoid breaking the instrument inside the root canals. All of us do this. All of you also must be doing this. You will check the file. You will use a pecking motion. You will brush against the side. So if it's a mesiobuccal canal, you will brush on the mesial wall, you will brush on the buccal wall. You will ensure you create a glide path, either with a hand file or maybe with a glide path rotary file nowadays. You will ensure that you sequence your file properly. You don't jump one sequence, okay, so that the canal is adequately prepared. You understand the risk of file fracture. You use torque control handpieces like what we discussed earlier. You will set the torque value, you will set the speed value, and you will use the file very carefully. But the real game changer, if you ask me, happened with heat treated nickel titanium files. So all of the rest of the things were things which we were doing in our practices to help mitigate it based on our personal experience. The heat treated nickel titanium files, this was the help which was provided to us by the manufacturers who worked in their labs tirelessly and found out how can we push this number of cycles to failure further and further away so that we can use the instrument more durably, safely, comfortably. So the advances in the alloy resulted in changing nickel titanium as we know it now, and we have more heat treated nickel titanium files which are available in the market. We will understand all about these heat treated nickel titanium files right now in this section, which is the most important section. See, like gold, gold has got malleability and ductility. So we know that this is the property which makes gold very, very useful for us. In dentistry also, gold used to be used because of these two properties. In nickel titanium, we all know the properties shape memory and super elasticity. We all know this. The metal came from the naval ordnance factory, and it had this particular property that whatever is the deformation, when it is heated to a particular temperature, it will come back to the original shape. This is called as shape memory. Super elasticity is when it is undergoing significant deformation, this alloy has the ability to immediately spring back to its original shape. So this is called as super elastic, like a spring. Now, the other significant property of nickel titanium, which we really need to understand and which the manufacturers have used, is the ability of this metal to exist in two different forms or two different phases, an austenitic phase and a martensitic phase. So it will behave differently depending in which phase it is. Also, it need not exist in either one of these two phases. It can exist in a mixed phase where it can be mostly austenitic, less martensitic, mostly martensitic, less austenitic. So there is a sort of a mix going on sometimes when required. But this is the key element that nickel titanium offers to us, which was used by the manufacturer to improve the alloy. So this happens in two ways. Either when we are using nickel titanium itself within the root canal, it is changing from austenitic to martensitic or from martensitic to austenitic inside the canal. When the temperature increases, it may change to austenitic. So stress will make it change phases. The other method is temperature. At the time of manufacture, it can be manipulated, and at the time of use also, if there is a change in temperature, it will change phase. So the earlier nickel titanium files, when you purchase them, assume that you bought a profile set, you would have got the file in an austenitic phase. It was already very stiff. It had super elasticity and it had shape memory, but it was in an austenitic phase. Why? Because martensitic is stable at a lower temperature. So those alloys only below 20 degrees, they would be martensitic. About 20-25 degrees, they would be austenitic by default. So we were dealing with a particular type of alloy. That is what has changed, where the manufacturers now are giving you files I'm sure now when you open the file from the box, you take your HyFlex CM or HyFlex EDM files and you take it out of the box and you bend the file, it does not straighten out immediately. It stays bent. So basically this has got controlled memory. Why does it have controlled memory? Because this file is not austenitic at room temperature. It is martensitic at the lower temperatures or at the room temperature. It is martensitic even at 37 degrees, which is the canal temperature. The temperature when the file is inside the root canal when it is rotating. Because it is martensitic in these temperatures, it is able to be more flexible, more durable. It has got more cyclic fatigue. So let us just emphasize on this point so that we understand what is austenitic and what is martensitic, because it is not just theory. This is fundamentally how we are going to be selecting our instruments, and we will understand what is heat treated. So if somebody comes and tells you, I am giving you a heat treated file, this is what they mean by heat treated. This file has been programmed to behave differently. It will change its phase and change from martensitic to austenitic at a pre-programmed temperature. So this is where I told you, when you select a file system which is maybe based on cost, less expensive, it may not change the phase at the specific temperature as the better designed file systems. So the austenitic phase, in this phase NiTi is rigid, and it is called as a parent phase because the earlier NiTi was all austenitic in room temperature. It is rigid and it is prone to fracture more. Whereas in the martensitic phase, all these files, okay, the martensitic alloy is more flexible and it used to be stable at lower temperatures. That has been changed using heat treatment. To repeat one more time, when an austenitic phase is cooled down, it will become martensitic. When a martensitic is heated, it will become austenitic. Repeating, when it is cooled, it will become martensitic, heated, austenitic. So why is this important for us? If you are using a HyFlex EDM file and it is highly flexible, mostly in martensitic, it changes to austenitic at around 45 degrees. You will not reach 45 degrees unless you are using heated nickel, heated hypochlorite inside the canal. So at 45 degrees to 50 degrees, it may become austenitic. Now this deformed file, the deformed flutes, very important clinical tip, in your HyFlex files, there is a distance between the cutting blades, the flutes. If once you use it, the flutes will slightly widen out. When you autoclave it, the temperature increases. This martensitic instrument becomes austenitic in the autoclave. So the instrument will now straighten out, the flutes will again come back to normal equitable distances, and it is ready to be used one more time. A tip, what I told you is, when this stops happening, when this deformed instrument no longer reforms after autoclaving, that is probably a good time for you to consider disposing of the instrument. So this is a small clinical tip. When you are using high quality martensitic nickel titanium alloys, you can actually predict when it is going to fail. Should you autoclave, you can even use a glass bead sterilizer. This is evidence based. You can even use a glass bead sterilizer and see if the instrument is recovering its original form and shape. So this is possible in controlled memory files. So this is where this change of phase is important for us.
Eh,
So repeating.
Sir, sorry to interrupt. Your voice is echoing a bit.
Okay. Let us see. If it echoes one more time, just let me know. I don't know if there are other devices in this room. We'll clear all the devices. Is it better now?
Yes, yes,
Okay. So
yes, sir.
better, no? All right. So the last one slide to again tell you, at the higher temperatures we are austenitic, at the lower temperatures will be martensitic. And I told you it need not be fully austenitic or fully martensitic. We may want a little bit of stiffness, a little bit of flexibility, more stiffness, less flexibility, more flexibility, less stiffness. This has been done by the manufacturer for you. So the manufacturer has put in 4 program temperatures into your files. At the highest temperature, it will be fully austenitic, that is beyond austenitic finish, AF. When the temperature reduces, it will finally reach a point where it will be austenitic start, and then beyond that, as you go lower, the martensitic phase will start. And as the temperature lowers completely at one point, at whatever temperature, whether it is 37 degrees, 30 degrees, 28 degrees, depending on what the manufacturer has decided, it will become martensitic finish. So if martensitic finish is 25 degrees, below 25 it is fully martensitic. And if the austenitic finish is 50 degrees, above 50 degrees it is fully austenitic. So above 50 it is very stiff, below 25 it is very flexible. This is assuming what the manufacturer has done. So with this said, we now know what is austenitic phase, what is martensitic phase, and we will proceed because some parts of this will have a bearing on what we are going to speak next. All heat treated nickel titaniums will come in this third vertical or third generation, and these heat treated nickel titanium files, they are increased in flexibility and increased in durability. Dr. Sneha, are we clear now? Can you just tell me?
Yes, sir, it is much better now.
Better now.
Participants, I hope it is better, everyone. Okay, sir, all good,
Great,
all good.
great, great. So this ability to transform.
Yeah, really sorry, sir.
Yeah.
Participants, you can just use headphones for better audibility because sir's voice is clear. I guess so 3-4 people are getting issues. Rest there is no complaint. Sir, if you can also use headphones or something, I guess that would be better because they are saying the noises in the background.
Okay, okay, okay. I don't know if there is any noise here. The thing is that I don't know if we can just. Uh, uh, is it clear at your end, Sneha?
Yes, sir, my end it is
Yeah,
perfect.
because we have both Sanjay and Shashi here. It is clear for them also. So I think
Yeah.
it should be limited to a few participants. So
Yeah, I guess 2-3 people are getting
yeah,
issues.
yeah.
Yes,
So
sir.
I think maybe those participants just try to see if you can use a headphone. I think that can
Yeah.
be like what Dr. Sneha told, because I think this is clear here. Everybody here seems to be. Just check my.
Yes, sir.
Is that-
Perfectly fine.
Yeah, yeah. We'll check at our end so that there's a certain amount of uniformity. But please just see if that can be done. So we'll proceed, Dr. Sneha.
Yeah, sure, sir. Sure.
So this ability to transform phases has been utilized in heat treated nickel titanium files, like I told you. So the older generation of NiTi, this used to be more austenitic, and the newer generations, they are more martensitic. Now the different manufacturers, they have got different proprietary treatments. So there are a lot of names that we hear. You know, you have manufacturers come and tell you, I have a blue file, I have a gold file, I have M wire, R wire. So I thought let's try to make some sense out of this. So the next time you see a file, you will recognize it differently. And hopefully you will remember this presentation and you will remember me. So what is M wire? M wire is a heat treatment which has been done by Protaper Next, Reciproc and Wave 1. So that behaves in a particular way. R phase, just like what we said, we have the austenitic phase and the martensitic phase. Somewhere in between your austenitic phase and the martensitic phase, somewhere in between there is a temperature 31 degrees, 32 degrees, where the file goes into an R phase. So this is an ambiguous phase in between both these, which has got particular properties. These properties have been used by certain companies to develop files. So Sibron Endo has used this for developing a series of files called as twisted files, where they have twisted the file into shape rather than grinding into the file, because nickel titanium is normally made by grinding. You cannot twist it. The same way the HyFlex EDM has been made with a non-contact process, which is called as EDM, electric discharge machining. Again, it is not grinding. So grinding is something which brings certain faults into the nickel titanium. So R phase has been utilized to twist the file into place. The same way a regular K file has been twisted, stainless steel K file has been twisted. We come to CM wire. You know, CM can stand for controlled memory. Now, Coltin uses this alloy for making their files, which is HyFlex CM and HyFlex EDM. So both of these files come with extremely high cyclic fatigue values, and I think HyFlex EDM, as per documented literature, it comes with possibly the highest cyclic fatigue values amongst all the nickel titanium files which are available in the market. So high flex CM is ground on the CM wire, and the high flex EDM is not made by grinding. This is made by a non-contact procedure. So there is no contact on the alloy blank at all. There is instead a non-contact procedure which goes on, which is called as electric discharge machining. So the high flex CM, because of the alloy, it is 300% more cyclic fatigue resistant than your conventional NiTi, whereas your EDM is 700% more resistant than your high flex CM itself. So this is how when you buy a new iPhone, you will read about how the camera is better than the earlier camera. So these are the kind of percentages that we can throw at you, and you will be able to quantify what sort of benefit you're getting from one generation to the next generation. Another very interesting benefit which the high flex EDM brings onto the table, I was part of a workshop with Anthony Ketoinis, who is a speaker for Coltin from Greece. So a very interesting point, in one of the techniques that he teaches on how to instrument calcified root canals, he propagates a method where high flex EDM is used for filing through a calcified root canal. You would wonder how. That is because the high flex EDM, because of this method of manufacture, which is the electric discharge machining, since it is non-contact, the surface of this file is very rough. Under an SEM, if you observe it, scanning electron microscope, it is a very rough surface. This roughness allows it to cut through calcified root canal. So that is a particular technique which has been propagated by Anthony Ketoinis, and very interesting techniques which we have also used. So there are sometimes when you understand an instrument, when you understand the geometry and the alloy of an instrument, you may be able to come up with some uses for the instrument which could be out of the ordinary. This is one particular example. The CM wire, the control memory wire, does not have super elasticity. As I told you earlier, it does, like shape memory and super elasticity are two particular properties of nickel titanium we all know. They have left out the super elasticity. Why? Because the challenge with nickel titanium was that you could not pre-curve this instrument. You are not able to pre-curve it. Now with the high flex CM and high flex EDM, you can actually pre-curve this instrument and introduce it into the root canal. Now where does this pre-curvature come in? Another very interesting technique, again by Antonis Ketoinis, is this TCA, or tactile controlled activation. It is a technique propagated by him, which we have also been trained under in a Coltin program itself, where you pre-curve the instrument, you introduce the instrument into the root canal in a passive way, and you only activate it once you have engaged the root canal, once you have engaged the curved root canal. When you use a high flex EDM file in this manner, you will be able to do very interesting cases using your rotary instruments itself. So I repeat, understanding the alloy or the metallurgy of the instruments sometimes can give you some really interesting techniques which you can learn. There are also instruments which come in different colors. We have the blue files, profile vortex blue and reciproc blue are blue files. We have gold files. We have ProTaper gold and Wave 1 gold. These gold files have got very high resistance to cyclic fatigue, but their only high flex EDM, as I told you earlier, has shown in literature to have higher cyclic fatigue resistance compared to any of the other files, whether it is the gold file or whether it is the blue file. So this is data which tells you that this file is really resistant to fracture. There are a lot of other proprietary names, a lot of tweaks which manufacturers have done. You have MaxWire, which is used for the XP endo shaper. You have T-wire, which two files for a canal. C-wire, which one file uses. So there are a lot of proprietary, techniques which have been used by the different manufacturers. So we will not get into them much. But we have now come to the end of this part of the presentation, and we have reached a certain level of understanding of alloy. I am hoping that we have reached a certain level of understanding of alloy. So with this, armed with this, let us proceed to the next part of our presentation, which is the next vertical, which is advances in the motion of the instrument. You may ask, what is the advances in the motion? We all know we have reciprocating motion and we have continuous motion. Continuous motion is what we use regularly. Reciprocating is when the motion goes back and forth. Now, your Coltine endomotor itself, it has got both the motions built into it. It has got both the continuous motion built into it and the reciprocating motion built into it. So you can use one of both. But there are other motions which are available for us in the market. We have something called as an adaptive motion and something called as an oscillating motion. In fact, one interesting learning which I had when I went to the Coltine headquarters, in the Coltine facility in Germany recently as part of the visit, we found the Coltine Gene instrument, which is an endomotor. They don't market it in India as of yet, but I think Mr. Farhat, the MD Coltine India, may look into it more favorably, seeing the inquisitiveness that we had regarding this particular motor. This motor has got an adaptive motion. So what is an adaptive motion? The motion, the instrument itself will recognize the torque inside the canal. You do not need to do much. It will be rotating continuously. It will reverse. It will then go into reciprocating. Then it will again start rotating continuously. So it will constantly, in a very intuitive way, start adapting itself inside the canal and make sure that your file reaches till the working length. Now, depending on the motor which you are using, you can use a type of file. So, the continuous motion, all your regular files you can use for your continuous motion. But when you are using a reciprocating motion, you will have to use a reciprocating file. You cannot use a regular file. The first time that the reciprocating motion was used, it was used on a F2 file. And they used the first motion to be clockwise and the second motion was counterclockwise. Later they realized that was not ideal, so all the reciprocating files now, they come with left aligned flutes, and the motion, the first movement in a reciprocating motion is 150 degrees, a big movement which goes counterclockwise. The second movement is a small movement of 30 degrees clockwise. So this counterclockwise, clockwise keeps going back and forth, and eventually the file will rotate a full 360 degrees. So what this does is, this is meant to potentially reduce the load of cyclic fatigue on the particular instrument. What is adaptive motion? As I have told you, there is a very interesting instrument which Coltine has got in with them called the Canal Pro Genie, and this has got a motion which will allow the motor to itself control the motion as you use it. And oscillating motion, as far as I am aware, is only used in one particular file system, which is a self-adjusting file. This is a lattice-like framework, SAF file, and it can be internally irrigated. So only that particular file uses this particular motion. Now with that, we know that there are 4 verticals that we have covered. There are 4 motions also we can use when we are using rotary files. What happened in the 5th generation? The 5th vertical of development, we saw a slight improvement in the design. There was a file system which came out called as OneShape, and of course ProTaper next, where the file's center, it is off-centered, the cross section is off-centered. Why? This was done so that when the file is rotating in the canal, the file is not contacting the whole canal wall at one shot. So it is contacting it in multiple areas. So when it is contacting it in multiple areas, the amount of load on the file will reduce. You get a swagger effect inside the file, and there is no screwing in or no taper lock which takes place. So it was a design change that happened. Now these were the 5 generations which were described by Hapesalo. Peters in 2022 added 2 more generations. Why? Because probably in that next decade, you saw a lot of new instruments coming in. A lot of heat treatment instruments started to come into the market, and we started seeing rotary files being made for very specific purposes. What are the specific purposes? You have glide path rotary files. So if you want to do your entire instrumentation only with rotary, you want to go in all rotary, you have sequences which have come in, like HyFlex has got the OGSF. Coltin has got that new sequence called as OGSF, orifice shaper, glide path, shaper and finisher. So there are 4 files over here, in which the second file is a very interesting file. It is a glide path file. So this glide path file can be used to create the glide path before you move on to the shaping part of your instrumentation. So it's a specific file designed for a specific purpose. We had files which were created with internal irrigation processes, like I told you earlier, the oscillating instrument. So self-adjusting files. This is a file which is made out of a process called as laser cutting, and it's a lattice-like framework which has got, and it's a single file which keeps grating against the walls of the root canal, and it's able to instrument the root canal. So irrigation enhancement happens. You had files which were made for retreatment only. HyFlex by Coltin. It has got a file called as HyFlex Remover, an extremely efficient file for removing gutta percha in your retreatment cases. We will talk about it a little bit later. I will show you a nice video where we have removed gutta percha using a HyFlex Remover. We have recorded it, so you can have a look at it. So you have suddenly this generation of files which have come in. Probably, if you read this, I think the article was by Peters himself. They are recommending that we probably come out with a new generation of files which may remove fractured files. So that is the future development for nickel titanium files. Maybe a new generation of files which, once you fracture a file, you have a specific file which will go in there and help you in retrieving the file. So all of these new types of files with unique uses, they will be put under the 6th vertical of development. Finally, we come to the 7th generation or the 7th vertical. Here all the different methods of manufacture. So how are files manufactured? Other than, of course, grinding is possible now in certain cases, but other than that, we have twisting of files. Why? Because when we grind NiTi files, the conventional method of manufacturing NiTi, when we grind it, you will create small micro cracks on the surface of the nickel titanium. These will act as nuclei for failure at a later point in time, these imperfections. So to avoid this or to mitigate this, we have files which have come out with newer ways of manufacturing. Twisting is one. Shape setting is one, where there are files which have got a curvature which is built into it. XP Finisher, Endo Finisher is one file system. There's a curvature built into it. When it is at room temperature, it will exist in an martensitic form. Like I told you, it is very flexible. But when you put it inside the root canal, finally in the root canal, the files will face body temperature, which is 37 degrees. So for all of you, people who are interested in research out there, please know whenever you do any study on nickel titanium, you should study it at 37 degrees. If you do the in vitro studies at room temperature, that study will have absolutely no value at all, because the file is working at body temperature. This file has been set up to curve itself into a different shape at 37 degrees. It even changes its taper at that particular temperature. So from 1% taper, it changes to 4% taper at that temperature. When you autoclave it, it comes back to the original shape. Laser cutting is a type of file system, like I told you earlier, not wanting to repeat, which is the self-adjusting file system. And finally, we have the Coltin HyFlex file series, the EDM file series. As I mentioned earlier, if you want to avoid grinding, the only way to avoid creating micro imperfections or micro cracks on the surface of nickel titanium, which may be the genesis of failure at a later point in time and may reduce your cyclic fatigue values, you would want a non-contact method of manufacture. That would be the ultimate, which has been achieved with this particular file system, which is HyFlex EDM, and that is why this file gives you a very, very high degree of durability, because it does not have those micro imperfections on its surface. So now that we've finished the tough part of the program, which is evolution of the file through the different generations, we know that we have newer designs, we have newer surface treatments, we have different manufacturing methods. So I'm hoping that maybe with this, it will take you about 5 minutes to just absorb this information, collate the information in your mind. So what we will do, we will take maybe a small 5-minute break over here. Dr. Sneha, Shall we? Exactly 5 minutes, and we will start one more time. So you can grab a glass of water and we will begin. Shall we do that? So this, just to recapitulate all what we have done so far, all the developments in the different nickel titanium files, all of these are basically aimed towards better cutting efficiency, better torsional performance, and increased cyclic fatigue. This is the point that we would want to drive home. Okay, so with this in place, next part of our presentation we will go to. Okay, so we will come back in exactly 5 minutes. It is 11:15 or 11:12 right now, so at 11:20 we will.
Okay, sure, sir, sure. We can continue in 5 minutes. Doctors, till then you can participate in the polls and quizzes.
Dr. Sneha, you can tell me when to start and I'll start because we are ready. Anytime you tell, we'll start. So let the poll and everything what you wanted get done. Please let me know. Yeah, 11:20. Allah. Uh, Dr. Sneha, shall we start?
Yes, sir, we can go ahead.
Video ತೋರಿಸ್ತಾರೆ
Participants, you can keep posting your questions in the Q&A box as well, and also participate in the polls and quizzes. Thank you, sir. We can start.
ಸಾಕಲ್ಲ ಅಷ್ಟು ಹೇಗೆ So we have finished the first part of the session, which was on the theory of nickel titanium. So I would like to tell you it gets even better as we go along because the first part was what I was a bit worried about. It was very theory heavy. Now we get to the actual crux of the problem, which is nickel titanium file fracture, and the cases and videos etc. will come towards the end. So the last third is the best part of the whole presentation. So don't go away. The dentist who has never fractured the end of a reamer file or broach has not treated many canals, and this is something that I would definitely agree with. So file fractures are a part and parcel of the life of root canal treatment. We cannot blame anybody, we cannot blame ourselves either. It is the nature of the game. how can we manage it best, how can we manage it ethically, how can we manage it in a way which is most beneficial or manageable for our patients. That is what we are trying to discuss over here. And in this, you have to know that prevention is better than cure. So we would ideally want to not fracture. So let us see how we can approach this whole sequence of events. If we start with trying to discuss how can we prevent it, and then we proceed to ways of managing it. Why is it that these nickel titanium files fracture? Well, it is possibly due to the unpredictability, I think, of NiTi, possibly due to overuse, because see, NiTi files are expensive, so there is a tendency for the clinician to keep using it, as much as he can or she can, so that they get maximum value out of the instrument. A lack of understanding of the limits of the material, which is very, very important. I think that is something that in this presentation I have tried to touch on in the first half of the program, and we have tried to throw some light on it. And of course, there are so many newer designs of NiTi which is coming into the market. You should always learn your tool, how to use your tool. Any instrument, any material, a clinical tip which I would like to share with you, please open that instruction booklet that the manufacturer gives you, and please read it. Of course, it will be a huge sheet, it will look like a newspaper, and it will have it in multiple languages. But what is specific to your instrument, what write-up the manufacturer gives you, this is based on a lot of research data. It is simplified and given to you. So the small nuances of how to use the material, how to use that instrument, how to use the equipment, it is written there. So all instruments are not the same. The workflow is going to be different for each instrument. The limits will be variable. There is a way you can optimize the way you can use that particular file. So please make it a point to learn everything about that specific file, and then again that will give you a slightly better possibility of minimizing fractures. Now, when we talked about unpredictability of NiTi, see, with stainless steel files, it was possible to predict. There was this lovely classification which was given by Sotokawa, where he put these 6 different scenarios where you could see that the stainless steel file was going to fracture. It was being damaged. There was some bending, there was some kinking, there was some unwinding of the flutes. All of this was not there. It was not there at all with NiTi, especially with the austenitic NiTi files. It would just fracture unpredictably. So that was one major issue with NiTi, the unpredictability of the fracture and no early warning system. To some extent, that has been covered now with the heat-treated nickel titanium. And like I told you about HyFlex series, if you see unwinding, which does not reform after your autoclaving, okay, this file is now at the end of its ability to get into that controlled memory, time to dispose it off. So some warnings we are trying to get with these NiTi files as we go along, but that is one issue. Hand versus rotary. See, rotary files are 7 times more prone to fracture than hand files. Why? Because it is rotating multiple times in the canal. So we spoke about NCF earlier, number of cycles of failure or number of cycles to failure. So this hand file is not rotating so many times in the canal. You are basically going to be doing some rotary motion when you are going to be using it. So you are using a file which is a rotary file which has got a limited cyclic fatigue life. So when you are rotating it multiple times, it is obvious that it is going to fracture many more times than the stainless steel file. So if you look at data in literature, NiTi files fracture many more times or significantly more times than your stainless steel files. Possibly has to do with their movement more than anything else. So what is the single most important factor that was found in literature when they tried to check? They took thousands of files from different clinicians, and they looked at these files, they observed them under the microscopes, and they checked to see how much wear was there on the files when the clinician decided to dispose of these instruments. So in this study, they found the single most important factor contributing to fracture of instruments was the clinician or the operator, because every clinician had a different yardstick at which point he or she would dispose of or would stop using that particular instrument. Somebody would decide, okay, I'm going to use every file only once. Somebody would decide 10 times, somebody would use it 20 times. Other people would track the file in a particular way. But when they checked the files which were disposed and they examined the files were having different, levels of wear and tear on them. So there is no real standardization to the point where it is disposed of. So the best way of preventing fracture is dispose the file before it fractures, because it has got a limited life. That we all know by now. These are some small tricks that I use in my practice for avoiding fracture. There's a very interesting small stopper what you can get. This was introduced by a company earlier in 90s or 2000s, where this stopper has got multiple leaves on it. So when you put this stopper on the file, every time you use it, you can remove one leaf. So there are 8 leaves on this particular stopper. So once all the leaves are gone, you know that it has been used 8 times. Also, in addition to that, it is not necessary that we know how many times we have used it. You have to factor in, all canals are not the same. Some canals are mildly curved, some are moderately curved, some are severely curved, depending on which classification of curvature you want to follow. Snyder has given an excellent classification, you want to read up about it. So, when you are instrumenting a severely curved canal, you can remove 3 leaves. When you are instrumenting a moderately curved canal, you can remove 2 leaves. So, based on that, the number of leaves will disappear based on what type of canal you have used the file in. So, this is possibly one way that you can track it. Recently, I came across a file box, which you can every time the file is used, you can turn this thing on. There's a knob on each area. You can turn it. So 1, 2, 3. So it works the same way that you have this stopper over here. So depending on what type of curvature, you can turn it maybe 1, 2, 3 stops more, and at least you can track your file usage using that. So there are people who have tried to innovate and have tried to help us out in trying to track the file usage. So you can try one of these things which will help you track your file. So what is the impact on outcomes of treatment? So when we fracture a file, does it really impact a file? So should we leave the fractured file behind, or is it that when you fracture a file, all is lost? Now there's a nice piece of literature by Seltzer. When they examined this, they examined endodontic failures, and they found that periapical repair could occur in endodontically treated teeth with separated files or with fractured files. So it was possible that the teeth did recover, the periapical lesion did disappear in spite of a fractured file being present inside. This was possible when the teeth had vital pulps present in them before the therapy. That means there was no large periapical lesion which was present within those teeth. So this is a very important factor we need to consider. So the presence of a preoperative periapical radiolucency rather than the fractured instrument per se is a more clinically significant prognostic indicator. So whether your treatment is going to be successful or not is dependent on the periapical lesion. So when you fracture the instrument, if it is in a tooth with a periapical lesion present, possibly you really need to address it. If it is not so, maybe you may be able to get away with it in spite of not retrieving the instrument. So let us look at 2 ways of viewing this. We can look at evidence and we can look at logic. I examined both. So I have summarized it for you to make life little easier. As per evidence, what we found that pre-existing apical periodontitis is a red flag. So in these cases, you really need to do something about the fractured instrument. Whether you want to bypass it, whether you want to retrieve it, you need to give it some logical conclusion. Otherwise, you can possibly take your chances without retrieving the instrument. The second part is the logic part. Now, at what stage has it fractured? So this will influence even the evidence part earlier. If logic tells us that if the instrument has fractured after you have completed the cleaning and shaping and you have dried the root canals, you have done a significant amount of disinfection in your, if it's a multi-visit RCT in your first appointment, if it's a single visit RCT in the first half an hour or so, you have done a significant amount of disinfection, there is no periapical lesion present over here, then you have fractured an autoclaved file inside the canal, possibly, you know, the impact on your treatment logically should be less. This is food for thought for you. Think about it. So what is the best option? Retrieval or bypass? Is it, see, in these cases, I always say it should not be that operation successful and patient is dead. So when you are going in there to retrieve the instrument, please remember there is a tooth over there which you are trying to save also. So retrieval of instruments is always a very destructive process. Whatever method we are going to be follow, it is more destructive than your endo. You have to take that into account. So bypass will always be a better option compared to retrieval. So I have documented a case over here purely with radiographs. We have documented some cases with videos also later, but this is purely with radiographs of bypassing, where a separated instrument is present in the mesiolingual canal of a tooth and a S1 protaper file is fractured over here, and this was bypassed. Okay, this was bypassed. So this is a satisfactory result. It's a very, very good result, excellent result. What happens sometimes when we get lucky with bypassing is that it comes out during the treatment. Later when we are instrumenting, we have seen many times we have bypass. So always go with bypass as the first option. When is it possible for you to bypass? You have to know everything we do clinically, we should be able to evaluate. Everything we should be able to evaluate. Only then are we doing it in an evidence-based manner. So when it fractures, just check, is it a short fragment? How short is short? Less than 3 millimeters is considered to be short in the world of file retrieval or fractured files. Okay, this is the general anecdotal evidence, if you want to call it. It's very anecdotal, but 3 millimeters is considered generally as a short fragment, whereas more than say 6 millimeters would be long. Between 4.6 to 5.7 is moderately long. So shorter fragment is easier to bypass. A visible fragment, I should be able to see it, not in the radiograph, I should be able to see it clinically. Here it is important that we are able to use some magnification, either a loop or a microscope. We should be able to see it, only then we can bypass it. But then again, sometimes even in invisible instruments, beyond the curvature, as long as we can feel it with our file and we get that sticky feeling, we can still work on that instrument and try to bypass with a very thin file. And maybe in straighter canals it's a little easier to bypass. Okay, you will not end up creating a ledge and making things more difficult for yourself. So these are three things: shorter fragments, visible fragments, and straighter root canals. How do we do it? Very simply put, we assess it under magnification. You determine the length, the curvature of the root canal, and the visibility. All of this in detail I will be covering later. How do we determine length, how we determine visibility, curvature, etc. Under the fractured file part we will be covering. We do some amount of coronal flaring. You can use either a GG drill, you can use a modified GG drill. How to modify a GG drill, I will show you with a video towards the end of this presentation. We can use a modified GG drill. You can use a large sized rotary file, which is martensitic. The recommended file for this sort of work is the Hyflex EDM 2% 60 file. Why? This is recommended by the man Yoshi Torochi himself, who is considered to be a pioneer in instrument retrieval. There is a kit made by him, by Yoshi Torochi, on instrument retrieval. Inside this particular kit, there is only one rotary file which has been put with all the other instruments. I will be showing you the kit and the video of the kit later in this presentation. The single rotary file which has been put in the kit is a Coltine Hyflex EDM 2% 60 size file. That is because it is a martensitic file with all the necessary properties. So you can coronally flare it using a modified GG drill, or you can coronally flare it with a Hyflex EDM 2% 60. Lubricate it. Lubrication is very important. We will discuss it a little bit later. EDTA can be used for the lubrication. Pre-curve and use a very thin file. How thin? Maybe a 8 is good. A 6 may potentially deform. If you can work with a 6, nothing like it. But as 8 or a 10 number file can be used for slowly trying to see if you can get some space between the fractured file and the dentinal wall with a watch winding motion. Advance very gradually. Try to slip past the fractured file and then recapitulate and irrigate constantly. Here, one small take home point: whenever you bypass the instrument, once you bypass it, don't immediately remove the file. Keep the file inside the canal once you have bypassed and do what is called as low amplitude filing. What do you mean by low amplitude filing? Don't file with long strokes, very short strokes, back and forth, back and forth, back and forth, but don't remove it. Because if you remove it, again trying to get past the instrument is going to be tough. But if you just do some low amplitude filing in the space, what will happen is you will tend to widen the gap which you have created so that it is easier for you to push in the next instrument or even the same instrument one more time. So that is the small trick which you need to know. So once you have bypassed it, then treat it like just any other case. Go ahead, complete your irrigation, complete your obturation and finish off your post endo. If you get lucky, if the file does tend to pop off in between your treatment, well and good, but otherwise you're still okay. So to repeat again, the challenges will be when the fragment is more than 4 millimeters, the challenges for bypassing, when the root curvature is more than 30 degrees, when the file cannot be seen under a microscope or cannot be seen under magnification. So to summarize, bypassing can always be the first option to consider if retrieval is looking difficult. If it is easy, like you can see the file bobbing around in the coronal third, just go ahead and remove the file. But otherwise, always look at bypassing as the first option. Sometimes the fractured instrument may accidentally come out during the procedure if you are bypassed. That means you are very lucky. Avoids collateral damage to the tooth structure, which may result due to retrieval procedures. So retrieving an instrument is full of dangers. You may perforate, you may create a ledge, you may further fracture the file which is fractured. You may break your own file. There have been times when people have fractured one or two more files in the endeavor to try to remove one file. Okay, so all of these things also we will show you later, but these are all these things that you have to consider. So bypassing is the easiest get out of jail free card that we have with us. Now discussing retrieval, removing, which is the most challenging option. Of course, this is the most romantic option. Everybody, when they see a file fracture seminar, they think, oh, let us see all these nice videos on removing a file. But we have now spent a substantial amount of time learning how to avoid file fracture, understanding NITI, understanding the consequences. So we are now better placed to make better choices. So what are the factors affecting instrument retrieval when we are sticking to the core issue of retrieval itself? There are many factors. So based on this, you can decide, do you want to retrieve or not? Is it difficult or not? Do you want to refer the case or not? You can decide, because see, these decisions are based on what is best for your patient, so that you can live to fight another day. So the tooth type, location, visibility, size, evidence, type of fracture, root curvature radius, operator fatigue, all of these have a role to play. And all of these I have collated information in an evidence-based manner, not just in the way that I feel fit. So the type of tooth, posterior tooth are more difficult. Why? Because the anatomy is more complex. The roots are curved. This anterior teeth, the roots are usually straighter. The canals are narrower. Anterior teeth, the canals are a little wider. There are curvatures, there are concavities, there are multiple curvatures sometimes. So iatrogenic accidents can happen more often in retrieval. Mouth opening is also less. As we go further and further back, second molar, we tend to find the mouth opening less. Many of the instruments we use for retrieval, they are very lengthy. The trephines which we are using, the gates which we are using, they are all very lengthy instruments. So it's difficult for us to operate in this space and get that sort of access. Visibility is tough in posteriors. So all these things add to the degree of difficulty. Maxillary teeth, relatively speaking, are easier compared to mandibular because the gravity is there to help us out. So all you need to do is loosen the instrument a little bit, use the ultrasonic. Higher possibility that the instrument is going to pop out little easier, less resistance. There is no gravitational resistance happening over here. So maxillary is easy, mandibular is more difficult. Coming to the location, which part of the canal has the file fractured in? Now, the chances of retrieval are high if the fracture is before the curvature, so it is in the upper part of the canal, the chances of you retrieving it are high. If it is in a curved canal, if the file is fractured around the curvature, somewhere towards the middle of the canal, it's a bit of touch and go. The chances are low if it is after the curvature. So after the curvature, visibility will be very difficult. Now, what are the chances of retrieval? If you really see literature, chances of retrieval is in the best of times 50. It is like the average good cricketers average. Like Sachin Tendulkar averaged 56 or 57 in Test cricket. So every time he went out, he did not hit a century. Every time you try to retrieve a file, you are not going to retrieve it. People succeed 50% of the time. Now, if you go through literature from the 80s onwards, 90s, 2000, 2010 onwards, you actually start to see an increase in the file retrievals. You can put it down to the use of magnification, use of microscopes, better instruments, heat treated nickel titanium files, better kits available. Earlier we only had the Mazarin kit, now we have so many newer kits which are available, which give us so many more options, better ultrasonic options which are available. So, and the files themselves, these heat treated martensitic files may be easier to retrieve. So due to various reasons, and protocols are better. So various reasons, the chances of retrieval has increased, but keep it, I would feel, for you to not be demoralized. We keep our chances of retrieval at 50%. We say that half the time I will succeed, half the time I will fail. So when the cases are easy, before the curvature, around the curvature, you will probably succeed all the time. The problem is when the cases get difficult beyond the curvature, it is quite challenging. Visibility is important. Success rate, as per literature, is twice as much for instruments which can be seen under the microscope or under the loupe as compared to instruments which cannot be seen. If you look at literature by Yoshi Tarochi on how to retrieve instruments, he categorizes the retrieval into two categories of instruments. Instruments which are visible, there is a protocol for it. Instruments which are not visible, there is a protocol for it. Mostly the protocols are same, except that in the initial parts of the non-visible instrument, we are working with a tactile feel. I will explain that to you later. So in the preparatory phase, we are working with a tactile feel. Only in the retrieval phase, it's almost the same. But the protocols will always deal with the instruments differently. Visible, non-visible. If you can see it under magnification, of course, it is easier for you to remove. The size of the instrument. The bigger the size of the instrument, the diameter of the fractured instrument, more tooth structure must be removed for removing. So collateral damage is more. Unfortunately, the files which fracture more often are the larger files, because larger NiTi files have been shown to be more prone to cyclic fatigue than the narrower diameter files. So this we know. The length of these files. As I told you earlier, anecdotally, and of course this has been put into evidence also in narratives, less than 3 millimeters is considered to be doable, relatively simple. Between 4.6 to 5.7, the number is very specific. Again, numbers given by Yoshi Tarochi. But between 4 to 6, let us say, you require more time, but it can be retrieved. More than 6 millimeters, you may have to use something else. Other than your ultrasonics, you may have to use maybe loops, etc., to grab the instrument and to pull it out. So this is a case which I will show you later. Long instrument fractured inside the root canal. All of these can be removed, but the techniques, instruments, methods may be slightly different in each one of them. The type of instrument fractured, this will have a bearing. Now that all of us know what is austenitic and what is martensitic, the austenitic instruments are like springs. That type of nickel titanium file constantly is trying to straighten out, and because of that, it's putting some pressure on the outer wall. So the austenitic instruments, when they are short, it is okay. When they are less than 3 millimeters, they come out relatively easily. But when they are longer, they are quite tricky to remove, and a lot of tooth structure gets removed in the process of retrieving these. They take more time, and the chances of them fracturing one more time in the canal also is very high. This is because of super elasticity. Whereas the martensitic instruments, I told you that in instruments such as HyFlex CM or HyFlex EDM, these are martensitic, they are not spring-like. So they are passively inside the root canal. So when you are trying to retrieve them, they are not fighting you in multiple ways. So as long as you are able to loosen them out, they come out, because they don't have super elasticity. We spoke about shape memory and super elasticity earlier. I told you that these files do not have super elasticity. So that helps us out a bit in these cases. Root canal curvature. Root canal curvature itself, if it is a sharp curvature, it is difficult for us to remove. So at what point evidence tells us that if the root canal curvature is more than 30 degrees, then more time is required. Also, when the root canal is very curved, visibility of the instrument is less when it is beyond the curvature. I told you, if the instrument is fractured before the curvature, somewhere over here, it's easy because it's in the straighter part of the canal. If it fractures somewhere in this area or whatever, still it is okay. If it fractures in this area beyond the curvature, it will take us more time. It's quite difficult for us to remove. And if the curvature is more than 30 degrees, it's very challenging. We also have something called as radius of curvature. If the radius of curvature is small, it is a very acute curvature. If the radius of curvature is large, then it is a very small, very slow curvature or very easy curvature. This is easier for us to work with rather than the acute curvature. So these are some ways that we check to evaluate difficulty, and I will show you how I use that method to just categorize the cases before we start work on them. Operator fatigue is very, very important because the preparatory phase and the retrieval phase, these are two phases. When you read articles on retrieval of instruments, many times even I was surprised that there would be lines will say you can retrieve it in 10 seconds, you can retrieve it in 20, you can retrieve it in 30 seconds. And taking longer meant taking 2 minutes. But we were taking a reasonable amount of time. But you have to divide it into a preparatory phase and a retrieval phase. The preparatory phase is when we are trying to get access to the file using maybe a GG drill, a larger file, etc. We get visibility of the file and we are able to loosen the file. Then we come to the retrieval phase. In the retrieval phase, we just remove the file. The retrieval phase will be very quick. But sometimes in curved canals, extremely curved canals, difficult cases, I will show you some, it takes quite long. So when it goes beyond 15, 20 minutes, 30 minutes, 45 minutes, the operator himself will get very, very tired. Your sense of judgment also will tend to vary. So this has to be factored into it. This has been documented in literature also. Chances of errors are high. Plus the amount of time that you're using these ultrasonics, etc. inside the root canal, there's a lot of collateral damage that goes on, which could compromise the outcome. I told you earlier that operation successful, patient is dead. So you need to keep that into, take that into account when you're doing these sort of procedures. So coming to instrument retrieval protocols. Okay, so what are the protocols we can follow? The first thing we need to do when we set out to retrieve instruments, you need a CBCT. This is recommended in evidence. Why a CBCT? Because now you can actually check where the instrument is, what is the length of the instrument. You can even check the canal angulation, radius of curvature. All of these things you can get from your CBCT itself. It will tell you if there's any bifurcation happening. So much information which we have to assume looking at a 2D image. We get, should we take CBCT or not? There's a burning question, a lot of debate. But then to settle the debate in 2015-16, the American Association of Endodontics, together with the American Association of Oral Medicine and Radiologists, they came out with a position statement. And they said, you can take CBCTs in these 14 situations. So they gave 14 recommendations. I suggest go through these recommendations from the point of view of endodontics, and you will be justified for writing that CBCT. Recommendation number 8, separated endodontic instruments. So it is indicated, it is justified, and it is ethical to take a CBCT, and we get a lot of information over there. What are the methods we can use? Chemical methods, surgical methods, and mechanical methods have been tried. Of course, we know these are on the table. Now, chemical methods, these are not really practical. You look at some of these chemicals, they are quite aggressive. As of right now, I don't think this is something we will be able to try, and it is not possible. So we will not spend time on that. Surgical methods, these ideally should be considered as the last resort when the fractured instrument is in the apical third or in the middle third of the root canal. Surgery can be considered as the first option when the fractured instrument is almost outside the root canal foramen. Like in cases such as these, where the fractured instrument is almost outside the root canal, it may not be physically possible for you to retrieve it. There have been documented cases like of these which have been retrieved, but it would be a moonshot to really attempt this. More practical for the patient, but when you do surgical methods, please evaluate the tooth properly. Apart from retrieval, make sure that you are able to do your evaluation of your tooth properly. See, is it a restorable tooth? Is it an important tooth? Is it a strategic tooth? Look at the crown root ratio of the tooth. For instance, this is a multi-rooted tooth. The fragment is fractured beyond the apical curvature. So the procedure that we carried out is almost similar to an episectomy over here, but we still have a really good distal root, and we have great crown root ratio with the mesial roots. The crown structure is good, very restorable, very critical tooth. All these things have to come into play. So you have to do your restorative evaluation of the tooth, because otherwise you're going to put the patient through a minorly surgical procedure. It should be justifiable. Please look at the options you have to look at when you're looking at surgeries. Take a full medical history for the patient. If it's a mandibular area, look at the location of the mandibular canal, mental foramen. If it is a maxillary area, nasopalatine foramen, maxillary sinus, all these anatomical structures what we look at when we do any surgical procedures. So all your precautions, permissions, consent letters, etc., what is required for an episectomy procedure, you please have to do that workflow before you start and then proceed. So in this particular case, a case where there is a fracture of an instrument, this can be treated with a episectomy, like a sectioning of the apical third of the root canal. So we have a case, this particular case, I think we have almost like a 4 or a 5 year follow-up, at which point this particular radiograph was taken, and it is still doing fairly well. But we have considered a lot of other factors before going ahead and carrying out that particular procedure. So that workflow is very important in surgical removals. Now coming to the regular method, which is our mechanical method. So in mechanical methods, there are two sets of things we need to consider. What is the steps 1 and step 2, if you want to call it that. Step 1 is a preparatory phase. What do we want at the end of the preparatory phase? Please remember, you want your file to be loose at the end of your preparatory phase. You need to get to the file. You need to hopefully see the file. Even if you cannot see it, it is okay. You need to ensure that the file is loose. So this is an image of a modified Gates-Gideon drill going till the file, all the way down, till I can see the file. After I do that, then I will take my ultrasonic tip and I will loosen out the instrument, maybe with some sort of a solution inside the root canal, and I will retrieve the file. So there are two parts to it. There is a preparatory phase and there is a retrieval phase. So please remember, there are two parts to retrieving. Now, two sets of methods are there. Okay, broadly we can put them into two sets of methods broadly. Methods where we use trephine burrs to remove the dentine and to create a nice moat or a trough around the fractured instrument. Following by this, we use instruments such as loops and ultrasonics for removing, or different methods, a second set of methods where we'll use ultrasonics for creating the space around your fractured instrument. Then we will use devices such as loops or ultrasonics for removing the instrument. So there are two sets of methods. So what are the tools? See, there are lots of tools over here. So there are tools over the years from the point we started using the Mazarin kit, the San Diego kit, IRS. So in this presentation again, a lot of videos we have right now. From now on, I told you it will get very interesting. We come to the audio-visual part. We'll talk about the Coltine activator. We'll talk about the Coltine microsuction tip, a lovely instrument. I have a nice video showing you about that instrument. We'll talk about the BTR pen. We'll talk about the Tarocchi file retrieval kit, Gates-Gideon drills, how to modify it. So all of that stuff, we'll start doing it from now with videos. So it will be quite interesting. Sit back and enjoy it. So starting with step 1, which is retrieval of gutta percha. Many times we get retreatment cases with a fractured file inside it. I'm sure if you look back, you jog your memory, you'll see these files have failed. Treatment has failed because of a fractured instrument, possibly. Why? Because the instrument fractured, the clinician was not able to instrument the full length of the root canal. So because whether it is a ledge, whether it is a zip, whether it's a perforation, part of the root canal is not instrumented, not disinfected. That is what has caused the failure, not the fracture itself. So first thing, we need access. So they may have obturated till the fractured instrument. You need to remove all the GP. Okay. So let us see how that is done. And this can be done using the high flex remover, which is a file which is designed for removing GP from the root canal space itself. So here we are using the remover in the palatal canal. It is the 7% taper, number 35, high flex remover, being used at around 600 RPM. So now we are removing from individual canals and we are verifying over here. The speed is tweaked a little bit. I'm not really sure of the manufacturer's instructions. I think it says around 400 to 450 RPM. But I prefer a higher speed because as you speed up the instrument becomes a little stiffer. So in retreatment cases, I've always found that it's better to have it a little bit faster. So I operate the high flex remover at 600 RPM. And nowadays we are very lucky that most people are doing single cone obturations. So the high flex remover just grabs that GP and just pulls it out. So we have a lot of cases where we have done this very successfully. So this is step 1, where we remove the gutta percha. And probably from this point, it was a tooth, if it was obturated till the fractured file, once we remove the gutta percha, we should be able to see the fractured file. We will evaluate the tooth and then we'll proceed to this next step. So everything is going to be stepwise. Step 2 is we want access to the file. So whether we are using trephines, these are hollow instruments. Trephines are hollow instruments which are mounted onto a micromotor, or whether we are using ultrasonics. We can use ultrasonics also and get access to the instrument. So the first step, whether we are using ultrasonics or whether we are using trephines, we need the trephine to reach till the fractured instrument. So we need to improve the visibility, we need to improve the accessibility so that we can introduce the trephine or the ultrasonic or the loop. So the Gates Glidden drill is modified and used to achieve this. I will show you how now. In case it is a curved canal and your Gates is a straight instrument, then you can use a high flex EDM 2% 60. This has been recommended by Yoshi Tarochi. It is evidence based. When you can use this when it is more than 15 degrees. Now when we use the gates, are all gates of the same size? No. So I would suggest you consider using the number 3 or the number 4 gates depending on what you want. Why? Because the number 3 gates will enlarge your canal to 0.9 mm, whereas the number 4 will enlarge the diameter to 1.1 mm. Now your trephine is 0.7 mm. So if you use the number 3 gates, you can introduce your trephine easily into this canal. Your loop, if you are using a loop, it requires a minimum diameter of 0.4 mm at least before you can introduce the loop into the canal. So whatever it is, you need to create space. That is called as a staging platform. So to create the staging platform so that we can introduce our trephines with a minimum diameter of 0.7 mm or maybe a maximum diameter of 2.4 depending on what trephine you want to use, we will use a GG drill which is modified. Finally we will reach till the root canal instrument and then we can decide. So even when we are using a loop, we require a minimum 0.4 mm diameter. If you are using a loop, you also need to expose the sides of the file up to a minimum of 0.7 millimeters before the loop can grab the instrument and remove it. I will show you that right now in a video. with this staging platform created, we now have access and we now have visibility. So we have modified a GG drill, created the staging platform, we have access and we have visibility. At this point, we can decide, let us try to see if we can use an ultrasonic. So Coltene, most of my retrievals here, they've all been done using this particular instrument, which is the Endo Activator by Coltene. It's a very interesting instrument because I use it for a bunch of things. I use it for activating my irrigants. I use it for instrument retrievals. So it comes with 3 separate ultrasonic tips. The CU1, which is a little on the thinner side, the CU2, which is quite thick, and the CU3, which is very, very thin. So depending on my need and what I'm trying to do, I will decide which tip I want to use. And it's got some built-in features, like it only is activated for about 20 seconds. So when I do my ultrasonic activation for my irrigation, I know that I've irrigated it for 20 seconds when I use this particular instrument. So there are a lot of inherent benefits over here. Now, when we use the ultrasonic tip, among the 3 tips, I would prefer using the CU3 from the Coltene Endo Activator tips because it is a narrow tip. When I use tips for retrieval or for loosening, I want to use a narrow tip. If I want, I can reshape my CU2 also using a burr. I will then apply it on the inner part of the curvature to loosen it, and I will try to make sure, as per this protocol, we try to make sure that we are able to push the ultrasonic at least to 1/3 the length of the fractured file. If it loosens, great. If it doesn't loosen, you can go a little bit longer also to maybe half the length of the fractured file. Once you have reached till this 1/3 length of the fractured file, you can even go in a semicircular direction and make a 90° to a 180° space around the fractured instrument on the inner part of the curvature. This is the part where ultrasonics will help you to loosen out the instrument. And this can then be further augmented using a lubricant to loosen it out. Why lubricant? Because ultrasonics work synergistically with fluid. When you put an ultrasonic and there's fluid in the canal, we get benefits of 2 different features with ultrasonics. We get cavitation and we get acoustic streaming. What is cavitation? Cavitation is when there are small bubbles which are formed which will implode, and acoustic streaming is when the file itself will cause the fluid to go around it from the top to the bottom and then back up. This physics will help us retrieve any instrument which is present inside the root canal space. So this is a great benefit of using ultrasonics. Now these physical properties of these ultrasonics, they help us not only in retrieval, they also help us in activating irrigants such as sodium hypochlorite. They help us in removing gutta percha. They help us in sealer placement. Short bursts of ultrasonics with this instrument will help you put the sealer into the root canal without any voids inside it. And the thicker tip, the CU2, I use it very frequently for locating canals. Sometimes you get these calcified canals, aberrant canals, narrow canals. You can locate it because it just removes the dentine very easily. So you can uncover canals also. So multiple uses are there with this ultrasonic instruments. So this is a video showing you this particular instrument, the Endo Activator. These are the 3 tips of different tapers and sizes we get with the instrument. activator. Now, along with that, we also have other instruments which we can use in instrument retrieval. One of the tools which is used is the loop. So there are very specific loops which you can get. BTR pen is one particular loop system which you can use. The loop has to be used once the instrument is loose. So please remember, this is the disclaimer, and we have learned out of experience, a tight fractured file will never come out with the loop. The loop will just open up. So you need to use the ultrasonic, you need to really loosen it. But sometimes the loose instrument will be inside, it will be bobbing up and down, especially when the length is longer. I told you initially, if the file length is more than 6 millimeters, you sometimes will need to use a loop, especially in curved canals. So the loop is a useful tool, but specifically for certain indications, and mostly once the file is loose. Before using the loop, just like what we did earlier, you need to create the staging platform. You need at least a 0.4 mm diameter. So I would suggest at least the GG drill number 3 has to be used, and trephine would have to be used, or ultrasonic has to be used to create this small space around it, at least 0.7 mm to about 1.5 millimeters, so that this loop can go and grab it. So let us see how that works. So that was the loop which we just had a look at, and like you saw, you require space for placement of the loop. So as we run through the tools, there are some kits which have got many of these which are assorted, and we can easily procure them separately, but some of them have been consolidated. So Yoshi Tarochi has consolidated most of these things we have spoken about and put them all inside one box, and that is called as the Tarochi file retrieval kit. I will just show you the video, because by now you will be able to very quickly comprehend, because you have seen the modified GG drill, you have seen the loop, we have spoken about the 2% 60 Hyflex EDM file which is there in this kit by Coltin. You will see it now, and you will see a DG16 probe, a slightly modified DG16 probe, and some trephines also. So since you are now familiar with all the instruments, you will understand this kit better. to what we spoke about, there is also a recommendation to use lubrication when you use your ultrasonics. Why lubrication? Because the benefit of acoustic streaming and cavitation, I will speak about that towards the end of the presentation, because there is one additional small section I put on how you can use ultrasonics for irrigation protocols also in the end. So the theory on it I will tell you then. But which are the irrigants we can use? You can use EDTA, but Tarocchi has also suggested the use of certain oils like soybean oil in addition to the use of EDTA. Now why? Because this is a bit of theory behind it. It depends upon the surface tension and the viscosity. So based on surface tension and viscosity, there are very specific irrigants which help us. So, but when you are trying to retrieve, always it is good to try to retrieve in a wet canal as compared to the preparation phase where you can work in a dry canal also. So now that we know the difference between these two phases, we can understand at what point we need to put the irrigant. And if you put the irrigant, the liquid, make sure you top up the chamber with the liquid, or at least till the middle third of the chamber. If you only put little bit of the irrigant inside the canal, the file will not come out. It will keep bobbing up and down inside the liquid itself. So you need to at least fill up half the chamber with the liquid, which is again an evidence-based suggestion. Now when you do activation with the fluid-filled root canal, the explosion of the small bubbles inside the canal, the cavitation, and the constant high-speed flow of the fluid inside the canal, which is acoustic streaming, will force the root canal to eject the fractured file outside as long as the fractured file is loose. So we now come to the last part of the presentation, where we will talk about, or we will just show some cases where we have retrieved instruments, okay, whichever we have documented and retrieved. What I have done is I have tried to just see if we can, in a color coded manner, try to document the degree of difficulty. So if you see 2 stars, if you see green, that's an easy case. If you see yellow, it's a a moderately difficult case. If you see red, it's a very difficult case, like our traffic signals. Okay, so let's see how that goes. So this particular case, where this was the reference note over here, it was referred with a separated instrument in the mesiobuccal canal and perforation in the furcation area. So in terms of degree of difficulty, this is actually a very difficult case. I remember, I think I did this about at least a couple of years back in the practice, where the patient came with a complaint of perforation and fracture. So there's a massive perforation in the mesial wall on the furcation area, and there was a fracture in the distobuccal root canal. But the patient was highly motivated for saving that particular tooth and did not want an extraction. So we did sealing of perforation over 2 phases because of the size of the perforation, and we did instrument retrieval also in this particular case. So that was the whole treatment plan. We used retrieval with the endoactivator, and we sealed the perforation off with a tricalcium silicate based material. CBCT was used to assess the perforation as well as to assess the fracture. The type of tooth over here, this protocol we are following, the type of tooth is a upper posterior. According to me, it is relatively simpler. Location, middle third, it was a bit difficult, took time to get to the instrument. Visibility was there. The size of the instrument, it was a 4 to 6% taper instrument, so it was a bit difficult. Length was about 4.5 millimeters. We now know that this is moderately long. The type of fractured file, it's a rotary file. Again, a point to note over here, rotary files, because they fractured due to cyclic fatigue, many times they'll be loose inside the root canal, as compared to hand files, which fracture because of torsional failure and they're tightly bound. So there's a difference between both. So the cyclic fatigue ones are a little bit easier to remove. Root canal curvature, it was in the straighter part of the canal, and operator fatigue, it was fatiguing, let's say that. So this was a moderately difficult case. The instrument retrieval was easy, but getting good results was challenging. But we have this patient on a 2-year follow-up, and I can say that we did very well, excellent follow-up we've had. And we do our follow-ups for all these retreatment cases, etc., for about 1 year. Post 1 year, data tells us that there will be no healing reversal in endodontics. So at 1 year, if we feel that the lesion has become smaller, patient is asymptomatic, we consider the case to be successful, and we stop our follow-ups. So this is a CBCT which tells us in which canal it is fractured, and this is after we have retrieved the instrument. This is the instrument. If you can size it up, I've put it next to a paper point. You can see it's a little bit more than 3 millimeters. This was the perforation. This was actually the bigger part of the challenge which we had to tackle in this particular case. But we staggered the treatment or staged the treatment in such a way that we were able to complete the root canal treatment and then seal off the perforation. So it went out in a particular manner. So this is the video of the case. You can see the perforations also over here. This is a relatively easy case, very recent one, maybe about maybe 3 weeks back. In the radiograph it looks very easy, but in the clinically it was surprisingly embedded in some amount of dentine. Like I saw the radiograph, it looked like it was just sticking out, but we saw it was embedded. But it was a very, very simple case. We just applied the ultrasonic and the instrument just popped out. But just to show you the different degrees of difficulty, I have put this one on into this presentation. So the tooth type is the lower posterior. The coronal third is the location of fracture. It was a visible instrument. It was a rotary file. The length was 2 millimeters, so it is a short file, so it should be easy. The type of file was rotary. It was in the straighter part of the canal. Okay, and there was absolutely no operator fatigue because it was very, very easy to remove. This was the pre-operative, and this was the instrument which was rotary, post-operative. So if you see the length, it is about maybe about 3 millimeters, 2.5 to 3 millimeters in length. Now this is a separated instrument in the 2-4 upper premolar. So if you want to rate the degree of difficulty, this is in the middle third, somewhere near the point of curvature. It was visible, but it was a rotary file. Length was 3 millimeters, but the location made it moderately difficult. There was a 15-degree curvature to it. Okay, so but you have to get to a point, make a staging platform, and then you will get access to it. And the canals were merging. After that, the canals were merging. So here again, we are using the after the staging platform has been created, just to reduce the length of the videos, I have eliminated some parts, and finally it's being retrieved with the activator. In this case, you can see I am blocking out the adjacent canal, because sometimes the file may pop out of one canal and go into the other one. So we are a little careful, put cotton or paper points or whatever before you actually start retrieving it from the root canal, which is a good idea. But finally the length, if you can see, was quite long. It's quite long. It was reshaped remote, quite long. This is the patent canal once the canal, the instrument retrieval was done. Now this is a case where the length was long. The length was long. It was a lateral incisor. So the degree of difficulty increases purely because of this highly unusual length. And the primary retrieval, after the preparation phase, the retrieval was carried out only with the ultrasonics here, not even with the loop, because it was a straight canal, but it was moderately difficult. Isolated, the canal located, bypassing done initially to loosen it out, because it was bypassed with a 10 number file over here, ultrasonic applied to it, instrument retrieved, and the canal then evaluated for patency all the way down. See, in cases such as these, if you can see the size of the periapical lesion, what we discussed earlier, these are cases you have to retrieve the file, because here there is a large periapical lesion present. Any part of the canal which is not instrumented, not disinfected, will probably predispose this case for failure. This is a case where we have retrieved from a 3.6, okay, a 3.6. It was a retreatment case. It involved removal of gutta percha initially. That part we have already shown you. It was a lower posterior. The location is beyond the curvature, so it was a bit tricky. There was no visibility, so this comes under the category with no visibility. A rotary file was fractured. Length was 4.5 millimeters. The type of fractured file rotary. Root canal curvature more than 15 degrees. So everything says this is a big red flag. It took a little bit of time. The retrieval took a little bit of time. So separated instrument in the mesiobuccal canal beyond the curvature. Here in this video, you will see the instrument. I think this must be the video. You will see it actually pop out. So you have to keep your eyes open. Only then you will be able to see it. And the coronal part is enlarged in these curved canals using a high flex remover. Okay, a 2% taper the GP was removed with the high flex remover, but in a curved canal you can use a high flex EDM 2% 60 also in these cases if you feel that that will help you improve the visibility. So in this case you will see that finally we have flushed it out, with a lot of force with saline, and the fragment will come floating out at any point right now. So even flushing it out also helps a lot, as long as the canal is loose and the root canal. Only thing when you are trying to flush out with a syringe, please remember that the needle should not be bigger than the canal. There should be enough space between your needle and the canal walls so that the file can come out. If the canal is not adequately prepared, then it is a little difficult to do this. This works with the ultrasonics also. Make sure your ultrasonics are narrow enough to allow the file to come out. So one of the reasons that your file will not come out sometimes is the ultrasonic tip is so big that it is not allowing the file to pop out. So you have to prepare the upper part of the canal sufficiently and use a moderately thin ultrasonic to allow for the space. This is another case where we have retrieved 3 fractured files from the upper right premolar. As I told you earlier, sometimes in the endeavor of trying to retrieve files, the clinicians may fracture more files inside the root canal. So when we saw this case, there were 3 files in which one file was actually mangled. It was the first time that I had seen a circular file inside a root canal, and they were all edge files. So it was a very, very tricky case. So in this case, I have used the Terauchi kit and used for retrieving at one point, especially for that mangled instrument. So in terms of degree of difficulty, it was difficult because it was in the apical third, in the palatal canal and in the buccal canals. There was no visibility. One or two were visible, one or two were not visible. The files were edge files, which are very, very difficult to remove. One file was 4 millimeters, the other 2 were 3 millimeters. One was an edge file, the others were rotary files. One canal was curved, the other was straight. Also in this case, there was a septa which was present. Underneath one, the last file was present. So we found that the canal, it was starting as 2 canals and then joining as one below the septa. So I have removed the septa in between using the ultrasonic so that we gain access to the third fragment, which was right below the septa at the apical third. So it was very tricky in many ways. So the video will display. This is removed with the Terauchi GP removal instrument. There's a very interesting instrument in the Terauchi kit called as a GP removal instrument with a triangular head. So that was used over here. And the last instrument was very difficult to find. It was not visible also. There was some length associated with it. We then later realized that there was a septa present and it was below that. So I have removed the septa using the ultrasonic. Finally we were able to see the instrument and then we have retrieved it. After loosening it, we have retrieved it. So you can see the flutes of this instrument. It's a very, very highly retentive instrument. So sometimes these instruments can just grab onto the dentinal walls and they make it quite challenging. So you really need to focus on the loosening and only then you should be able to remove it from the root canal. So all H files of varying lengths. The last one was quite long even though it was at the apex. But cases such as these with a periapical lesion, unless you retrieve it, the chances of success are extremely slim. This is a case, I think we have retrieved a glide path instrument from the upper right second molar using the Coltine endo activator, and we have used the Terauchi kit in this case also to help out. So this was the difficult case, upper posterior, it was upper 7. Visibility was tough. Location was the coronal middle third beyond the curvature. Initially not visible, but we made it visible while making the staging platform. So the staging platform will sometimes change the conditions of working for you and make things easier. It was a rotary file. Length was long, 4.5 millimeters. It was an austenitic file, so it was trying to straighten out. That made it very difficult. Canal curvature 15 degrees. So again, a difficult case. But this last part I have recorded just to show you the file coming out of the canal. We've captured it from a screen itself. So the image is not that great, but it was a fairly lengthy instrument. And like I said, this took some time. This took some doing, took some time. But I think the importance of staging platform was significant in this particular case. So here we have removed the instrument and we have retrieved the file over here. Coming to the end of the cases, we have a fractured file in the mesolingual canal. This I have already shown it to you. It was a bypassing case. So mesolingual canal, again degree of difficulty in these cases because of the lack of visibility would be considered to be high. But bypassing is also an option which we can always consider in instrument retrieval. So don't think that you need to get in there and try to retrieve everything. Always the take home message is start trying to bypass. If you can bypass, well and good. During the later instrumentation it comes out great. If you're going to keep it behind, nothing like it as long as you've disinfected it well. Finally, we are done with all the retrieval videos. I will just put couple of cases over here. This is from where we have things to consider. It is food for thought. So this is a retrieval which we have documented of, and we've actually published it, of silver cone. It's a very old case of mine, but we have retrieved 3 silver cones, and we had made a protocol on how to retrieve silver cones. Things have changed a lot since we did this, and the type of tips which we recommend, we will, we have upgraded the recommendation also. But very rarely, in cases where the patients have been going to senior clinicians, you may end up getting cases. Even today, we get cases with silver cones in them. Silver cones were great obturation materials. If there is no periapical lesion, you can leave it behind. You really don't need to bother. But in this case, there was a periapical lesion, so we had to retrieve. They tend to corrode inside the root canal and they stay behind. So you'll have to loosen it out, and then later you can use ultrasonics Those days we used to use the Steglitz forceps and we used to pull it out. But sometimes the instrument, the silver cone will be very brittle. But ultrasonics has made it really very easy. So you just use a lubricant, use ultrasonics, and it should be fairly straightforward for you to remove it. And finally, please check your cases. This was a case which was referred to us at our practice. So I was told that there was a silver cone inside the root canal. So even we felt that it looked like a silver cone. It looked like a really, really difficult case. So the case had an anterior FPD. So the clinician felt that that had to be removed because there's some infection with one of the teeth which was serving as an abutment for the FPD. FPD was from the central incisors to the canine. So it could not be left behind. Retrieval was challenging. Removal of the FPD was risky since it was an anterior case. The condition of the tooth underneath was very questionable. So I was asked, can you retrieve it or not? And it was assumed that it was a silver cone. But on examination, even we checked underneath the microscope also, we later we took a CBCT and we came to the conclusion this was not a silver cone, this was actually a fiber post. So if you look at the straightness, this is a fiber post, almost very straightforward. But sometimes, when we are looking for something hard enough, we will find it. So I think we were looking for a silver cone. So I think it was assumed it was a silver cone. So then we referred the patient back to the original clinic and we said that this looks like a fiber post, but there is no GP, there is no obturation done. So it appears that it is a filling material. But in this case, I think the filling material itself has been the fiber post. Maybe the instrumentation was done, looks like an immature canal, and then the canal was obturated. So be very careful when you set out for retrievals. Make sure you know what you are getting into and you are selecting the right cases, because sometimes we may embark on retrieval and we may be unsuccessful because our initial determination itself of what type of instrument or determining the degree of difficulty may be faulty. So with this we come to the end of mostly what we need to speak about, but I will give you one little bit of a bonus, which is the use of ultrasonics in root canals. We have about 3 or 4 slides on how to use this instrument, if you want to use it for activation, because I primarily use this instrument for activation. I also use it for retrievals. I have found it to be the go-to instrument for activation for me because it is cordless. I also used to have the Coltine Biosonic earlier. So there's one video over here which I've done with the Biosonic and with the ultrasonic adapter, but I find this to be much more easier, much simpler, and it generates about 38 kilohertz of frequency, which is more than enough for most of our purposes. So all those cases I showed you earlier, I've done the retrievals using this itself. And when you're doing instrument retrievals, you don't want a lot of force. You want minimum force. You want acoustic streaming and cavitation to take over. So even in documented reports, they say you should use 30% of the force, not more than that. So this instrument is ideally suited. It gives you 3 different levels at which you can activate the force and 3 different tips of different sizes. So when we use ultrasonics in root canals for disinfection, what are we using? We are using the process called cavitation and acoustic streaming. This cavitation acoustic streaming also will help us in our retrieval also, and also in terms of our disinfection. So it helps in removing the biofilm. The explosion of the bubbles helps us in removing the biofilm. It helps us in removing the debris, and the acoustic streaming helps us in removing the debris and improves the chemical activity of the irrigant. The key thing over here is you have to make sure you use the ultrasonic once the instrument is the canal is reasonably wide, and the tip should be a little bit on the thinner side, because if the tip cannot vibrate inside the canal, you will not get cavitation and acoustic streaming. Please remember that. You can see with the way that the fluid is bubbling itself that there is no real ultrasonic activity happening. So that is one small take home message over here. Finish off your instrumentation and then use the narrowest size ultrasonic tip that you can. This is another lovely instrument which is made only by Coltine. We in fact went to the facility where they manufacture this instrument in Germany this time, recently, a couple of weeks back. And it is a real beauty because I use it for my retreatment cases, and there is a irrigation protocol I will show you which I use, which I find only possible with this particular tip. Even sometimes small fragments of Gattapercha which are there in our retreatment cases, you can suck it out like a vacuum cleaner with this. So it's a Coltine Roico Surgi tip. They make 2 surgical tips. One can be used for your surgical procedures like your implant procedures, etc. This is the endosurgical tip. Both are really excellent well designed tips. You can bend them in whatever direction, and they're very, very thin. And the length, make sure that you can see what you're doing. The thickness is actually away from your axis opening area. So I will show it to you in this particular case. Here I've used the Biosonic. I'll show you one more case where we have used the endo activator, but the principles remain the same. So what happens when you use an ultrasonic for activation inside a root canal? And how do you dry the root canal using the Royco Surgitip? So you can see, because of the length of the narrow part, you can see very clearly what you're doing. It doesn't interfere at all. And those round portions, they help you really bend this tip in all sorts of directions, and it remains stable. This is activation. So activation is we fill the canal up with an irrigant, say hypochlorite in this particular case, and then we run the file inside for about 20 seconds. I will show you the activation protocol. With the endo activator, which we use right now, it runs only for 20 seconds. So you don't need to worry too much about looking at the time. You just put it inside, start it. In 20 seconds, it will stop vibrating, and you are done. And you can proceed to the next canal. So this is what I told you. We do simultaneous irrigation. You can irrigate and leave that tip inside one of the canals. So you can put in large volumes of whatever irrigant you want to put in, and nothing will come out. Nothing will come out. This is removal of GP. You can see that small fragment of GP. It was bouncing inside the root canal. I just put the endo tip inside, picked it out from the root canal itself. So many applications are possible with this very interesting device. And very quick drying of the root canal. So it really speeds up your workflow also. So what do ultrasonics do? Data tells us that ultrasonic activation gives a significantly higher efficiency in removing debris and smear layer, and also in biofilm elimination. So I told you we have a biological problem. So the biofilm is very retentive. Lot of strategies for eliminating biofilm. We cover that more when we talk about retreatments. But ultrasonics are definitely on the table when we're trying to do that. So ultrasonic activation is better, than sonic activation. So sonic is less than 20,000 kilohertz. You have all those plastic instruments which you use. What they are doing is they are doing agitation. They are not doing activation. So you have agitation and activation. You should know the difference between both. Ultrasonics are anything about 30,000 kilohertz. So 30 kilohertz. So 30,000 hertz. So that is where we are getting activation happening. So that happens with these ultrasonic instruments. How do you irrigate in these cases? You irrigate with sodium hypochlorite, and you keep the sodium hypochlorite in the canal with the ultrasonic tip for 20 seconds. And then remove the hypochlorite. You can remove it with your endo suction tip. Put in some more hypochlorite, and again put your ultrasonic for 20 seconds. You do this 20-second cycle 3 times. So totally you have activated the hypochlorite in the canal for 1 whole minute. That is the evidence-based way of activating hypochlorite, and that should give you the result that you would expect. So this is the protocol for ultrasonic activation. Repeating, irrigant is refreshed 3 times in each root canal. Each time ultrasonic activation is performed for 20 seconds, and we get a total of 1 minute of activated chemical irrigation inside the root canal, which will disinfect it and also remove the biofilm. So there is a small video here which will tell you about it. We use the endo activator and the Surgitip. So this is an easy canal on which to show you this. It's a premolar. So 2 orifices meeting into 1 canal. So we really require a lot of ultrasonic over here to make sure that we get good disinfection. So 20-second cycle, irrigation with hypo, activation, and very quick drying with the endo tip. It's very quick, under 2 seconds. So very fast. So you can see the speed. Again, this runs for 20 seconds. The video is fast forwarded a little bit. Drying, you can see the speed of drying. It's just instantaneous. And finally, we have the last cycle. So with this, I'd like to thank you. And this is again one takeaway trip, photograph from our trip, what we had to the Colteen facility in Switzerland with my friends Dr. Adarsh and Dr. Mukut. So I'd like to thank Colteen for giving me an opportunity for sharing whatever little bit of knowledge that I have with all of you. And I'm hoping that you will have a few, like I said, it is one or two nice take home points from this presentation. And I hope it benefits both you and your patients in your practice. Thank you.
Thank you so much, sir, for such a wonderful presentation. The knowledge, the insights shared were really very, very pleasing and very, very informative, sir. And I hope all the participants have really enjoyed the session. The in-depth knowledge about the activator, the files, the metallurgy was really very easy and simple to understand, sir. So we can thank you so much, participants, for such a good participation and attendance. So we'll just have a 5 to 7 minutes break. We'll just run two polls till then, sir, and then we can have a small demonstration, and then we can start with the question answer round. And also, sir, we'll be announcing the lucky draw winners after you come back, sir. So we can have a 5 to 7 minutes break. So participants, you can start posting your questions in the Q&A box or on the group. And sir, after the break, we can start with the
Absolutely.
session and
Yes,
answer
done,
your
done.
questions
Okay.
shortly.
Thank you. Thank you.
Doctors, kindly participate in the quizzes and polls, and also shortly we'll be announcing the lucky draw winners. So the session is not yet over. Please wait for it. So kindly participate in the polls and quizzes, because we'll be sending gifts also to the poll winners.
Quarterly.
Perfect. Thank you so much, sir. So participants, we can start with the demonstration now. Sir, you can start with the demo part for the activator. And the polls and quizzes are running simultaneously. You can participate in them as well.
Can you hear me? Can you hear me? Can you hear me?
Yes, sir.
Neha, there is sound echo. Just ask Sanjay to clear that sound echo first.
Because two systems. Sir, you can just mute your
At least one
laptop
system
and
should
sound.
be mute.
Because there was
Now
echo,
can
so
you
you
hear
can
me?
just mute. Better, sir, better.
Dr. Sneha, can you hear me now?
Yes, sir, much better. You can start with the demo, sir. Now your laptop screen is visible, sir. You'll have to just screen mirror to the phone and then you can start for the demo.
Okay, Dr. Sneha, you can hear me now, I suppose, correct?
Yes, sir.
Dr. Sneha?
Yeah, sir.
Okay, because there are multiple devices in this room. So,
No, it's perfect, sir. It's perfect. You can start.
okay. Now, the reason is I'm just trying to see if we can do the streaming or not. If we can, we'll do it. Otherwise, we will proceed with the question and answer. Okay?
Acha.
We'll just see if this works. Okay. Is it audible now?
Yes, sir, it is.
Audible. Okay. We are okay
Your
right now?
screen sharing is on. Sir.
Great. So, what I'll try to do is which orientation is good. We will see. 1 second. Yeah, I think this would be better. Or we'll keep it like this. Patlu. Yeah. Okay. So what we'll do. Uh, Mostly whatever we wanted to show, we have shown it in the videos, but I'll just
Yes, sir.
familiarize you with the activator so that that part is done live.
Sir, can you just move the phone a little closer because your voice is like coming from a distance?
That Shashi will be doing it. So anyway, so these are the three tips that we end up getting with the activator.
Yes, sir.
And this is the device. So we also get a chuck, okay, with the activator. We get like a tip chuck or a burr chuck. So you can just take this tip. When you get it new, it will not have any bend in it. So we take it, we attach it. It is just this easy for us to do it. And once you attach it, you can then put the chuck into it and tighten it couple of times, and it's fully tight. And of course, the method of bending the tip is again the chuck is going to be introduced over here, and you will just bend it to whatever shape you want. Now, once it is in place, there's just a on and off button over here. You hold it down, and the light will start glowing. So inside this, you have this. There's a purple, there's a green, and there's a blue light, and this will indicate at what levels the instrument is operating, whether it's low frequency, a mid frequency, or a high frequency, depending on how much power you want. The output is 38 kilohertz, like I told you. And the good thing about this instrument is that when you press it, this light will ensure that you know that it is working. So whenever the light is on, it is working. Every 5 seconds it will beep, and it runs for 20 seconds. At the end of 20 seconds it will stop. This is probably been done maybe with the idea that when you're trying to activate an irrigant, you need to be activating it for about 20 seconds, and then post that you have to just press it one more time. So it's a very easy to use instrument. And like I said, these are the same tips that we have used throughout the presentation for all the retrievals. So what I have opened up over here is the CU1. It is mentioned over here. You can see it over here, it's working, the CU1. Now in addition to this, we have the CU2 and the CU3. The CU3 is the thinnest of the lot, whereas the CU2 is a little bit towards the thicker side. So you can see the CU2, it kind of bends fairly easily. So this is very good when we're trying to do retrievals, and even if you're trying to do any ultrasonic activation, it is quite useful. And this is the CU2. This is a fairly stiff tip. The CU2 does not bend. Once you bend it, of course, it will stay bent. May be useful when we are trying to do canal location, orifice location, managing calcified canals. So each one of these tips will serve a specific purpose, which you can use in whatever clinical indication there is. So with this, we have familiarized you with the instrument which we were speaking about today, which is the endoactivator. And I think we can go back to the webinar itself. And if there's any questions, I can answer those questions, Dr. Sneha.
Thank you so much, sir. So participants, you can start posting your questions in the Q&A box or on the group. Yes, sir. Thank you so much for the demonstration and the lecture session, sir. It was really very helpful. So, sir, we can just announce the lucky draw winners because everyone must be waiting. So, sir, kindly pick up numbers from 1 to 50, random 5 numbers, sir.
Okay. You want? I'll just call out the
First
numbers then.
50 paid registrations, early bird.
Okay.
Out of those, 5 will be sent gifts from Coty in India, sir.
Okay. So I will call out the numbers randomly. Okay. Number
Yeah, sir.
1 must be the first registration. So award for first registration. Number
So
1,
one,
number
na?
2, number
Huh?
1, number 25, and number 50.
Okay. These are 3, sir. 2 more.
You want 2 more. Okay.
5
We'll
in
go with
total, huh?
number 15.
1, 5, huh?
Yeah. And number 24.
Okay. So, sir, we have 1, 25, 50, 15, and 24. So, I'll just read out the names also. The ones who have won in the lucky draw. So, on number 1, we have Dr. Sheetal Bora, who's from Rajasthan, Jaipur. Then on number 15, we have Dr. Malav Thakkar from Rajkot, Gujarat. Then on 24, we have Dr. Swastika Bhaskar from Coimbatore, Tamil Nadu. Then on number 25, we have Dr. Rajesh V from Kerala. And then on number 50, we have Dr. Pavitra Devi from Palladam, Tamil Nadu. So congratulations to the winners, lucky draw winners. And we'll be shortly connecting with you for your addresses. Thank you so much, sir.
Okay.
So sir, I'll just start with the questions, sir.
Yeah.
Okay. So first question, sir, would you please provide information about different temperature phases changes inside root canal while using rotary file that will lead to austenitic start to martensitic finish?
Yeah, this varies from system to system. Okay, so what I will do is, for instance, if you look at your HyFlex files, the HyFlex files change over to austenitic at around 45 degrees. Below 45 degrees, they will be martensitic. Okay, but it is a variable from system to system. Like I told you earlier that that R phase instrument, those R phase instruments, they change from austenitic to martensitic somewhere around 31 to 32 degrees. And also uh, the at 45 to 50, it may be fully austenitic, but below 45, maybe around 37, 38, it may be partially austenitic, but it will be mostly martensitic. Okay, so the exact temperature will be a very proprietary thing, but it will not be constant for every instrument system. It will differentiate. I can tell you for HyFlex, it is around 45 when it becomes fully austenitic, 45 to 50. So when you hit it more than that, it will recover its original shape. So we spoke about controlled memory. Below that it is martensitic, it will maintain its deformation. When you hit it anywhere around above 50 degrees, or when it goes to an autoclave, I think it goes around above 120, 121 degrees, it comes back to its original form.
Thank you, sir. Next question, could you please explain screwing effect and how to avoid it or go about it?
Yeah, that the screwing in effect or the threading in effect was the problem that we had to deal with aggressive files in the initial stages. You know, we were operating them at about 250, 300 RPM, and they were greater taper files. So if you see the greater taper files, ProTaper for instance, we used to use a lot of that earlier. So F1, F2 and F3. F1 was the tip size was 7%, F2 the tip size is 8%, and F3 the tip size is 9%. But it doesn't stay 7% only. As you go higher up the file, it becomes 8, 9, 10, 11, 12%. So those files are very thick. And second, they had this triangular cross section. It had a very, it has a positive rake angle, very aggressive. So it is to bite in and it is to, like push itself in. So in those files, it was more a mechanical thing what we used to do. So possibly proceeding in a little slowly, making sure that you have finished your coronal enlargement and your middle third enlargement and your apical third enlargement in a slow manner rather than trying to push it in continuously in one go would be one way that you can mitigate it. Possibly just making sure that you hold the file in such a way that it doesn't get pushed beyond a point. That also we used to do, really, to be honest. The last 1 or 2 millimeters, very careful the way we put our rest on the adjacent tooth or on the same tooth, so we do the file doesn't thread in. Less so with the newer heat treated nickel titanium, because these files are more flexible. They have ability to slightly unwind their flutes also, so they're much softer. You will realize when you work, in fact, when you work with HyFlex CM and HyFlex EDM, you can pretty much, you'll get a feel. It's very difficult to explain it, but it's a very tactile feel where you can see that the threading in is much lesser than what it used to be with the earlier generation of files which we used to use.
Thank you so much, sir. Next question is by Dr. Salim. Can we do obturation of the enlarged apical foramen with ZOE by just shortening the gutta aperture to 1 to 2 millimeters from the apical foramen?
Yeah, that the question will be more towards, I think, obturation, but if the question may be two aspects to it. Choice of sealer. ZOE is a sealer which can be used. There is no real case to say that it is not a sealer to be used. I'm sure that the majority of the clinicians are actually still using ZOE most of the time, majority of them. Of course, now with the advent of all the tricalcium silicate based sealers, resin based sealers, we are more frequently using these sealers, but ZOE has not lost its benefit. If you really see data also, ZOE does have all the properties what were recommended by Grossman when he said that sealers should have these ideal properties. He said it should have easy to use, economical, easy to remove. All those aspects are fulfilled by ZOE. What does ZOE not fulfill? It does not have any bioactivity. That is what has been brought onto the table by your bioceramic sealers. And the push-out bond strength of ZOE may not be as high as your resin-based sealers, which is your AH plus, etc., that particular generation. But what it brings onto the table is it does have antimicrobial activity initially, in its initial 1 week of usage. That said, all sealers do not seem to have any significant antimicrobial properties beyond a particular point in time. If you see literature, most sealers lose their antimicrobial properties after about a month. So data doesn't tell that your tricalcium silicate based sealers are antimicrobial for a longer term. They are for a shorter term when they have their high alkalinity available, when they perform well with their antimicrobial properties. So all said and done, ZOE is still a good sealer to be used. The second part of the question is working length. Now working length, do you want to keep it at working length? Do you want to keep it 1 millimeter short? Do you want to keep it 2 millimeter short? It is dependent, really, if you look at theory, dependent on the type of periapical lesion there is in that area. I feel what you should see is just how we spoke about fractured instruments, how success and failure is determined, whether you want to leave it behind or not is determinant on whether there's a big lesion or not. Dependent on whether there's a lesion or your working length has to be stricter. So if there is a big lesion present, you need to be really strict with your working length. You need to be as close as possible to the apical foramen or the apical constriction. That is not the radiographic apex. That's an entirely new whole big discussion itself. But you need to differentiate what is the radiographic apex and what is your apical constriction. So working length is from your apical constriction, and the distance from apical constriction is not really very, very significant or important, let us say, in a case where there is no apical periodontitis. But in cases where there is apical periodontitis, there is the presence of a periapical lesion, then the distance from the apical constriction is very, very important. You need to keep your working length very, very tight.
Thank you so much, sir. Next question, how to avoid ultrasonic tip fracture while trying to retrieve fractured endophiles?
Yeah, that's a very interesting question. To be honest, I have encountered a lot of I have recovered fractured ultrasonic tips also from the root canal. I think you have to go with quality. I'm telling you, you really have to make sure that you're, again, just like files, you don't buy on cost. When we buy on cost, the chances of failure is very high. So there used to be this really, we have experienced, sometimes we have received certain ultrasonic tips by certain sources, and they've told us, why don't you use it and see if it works. And I've seen they've been so brittle, because the alloy is the key. And I'm telling you, with this particular kit, the Coltin Endo Activator, I have been using it from at least the first set. Where I was, the company had asked me to use it initially, and they asked for some sort of a feedback, and this is the feedback I'm giving right now. It is a phenomenally, durable kit. That said, it may fracture tomorrow morning. I've jinxed my kit right now, but it has not fractured as of yet. I'm still using the first set of ultrasonics that I've had, and I've really, really used it. But there have been ultrasonics I have used, and within the third use itself, it fractures. So a metal can be brittle, alloys can be brittle. So when you're operating at 30,000 kilohertz frequency, that brittleness will get amplified, and the possibility of the ultrasonic fracturing is going to be very, very high. So it is a really unfortunate accident if it fractures also in the canal. But if it fractures after you use the ultrasonic several times in the root canal, the canal will already be widened quite a lot. It comes out very, very easily. I have never left an ultrasonic in place when it has fractured. But you have to make sure that you invest in the right quality, because these companies have got a lot of, because we visited the cold tin facility as I told you, and we were checking how the quality checks are being done. Even on these Hyflex files themselves, there is this QC. Every single file, every single burr is checked under the microscope, and that the QC will keep taking in these 10 burrs. I was surprised that every single burr we get in the box here in India would have been checked in Switzerland for its quality, for the distribution of the diamonds across. If there's any gaps present, all these things cannot be done at with all the manufacturers, let us say. So if you buy it from a reputed source, the batches will be validated, the quality will be checked, the possibility of failure is going to be lesser. And make sure that you're using the right frequency of ultrasonic. Don't use a high powered ultrasonic, because each of these things, see, ultrasonics, you get ultrasonic scalers, they operate at a particular frequency. You get ultrasonic surgical units, they operate at a very high frequency where you can cut bone with ultrasonic. You get these sort of devices, they operate at a different frequency. So you need to know which device you're using, for what purpose you're using, what tip are you going to be using with it. If you do this much, the chances of you being able to reduce the possibility of failure, you will be higher. Elimination will not be completely possible, I cannot guarantee it, but reduction will definitely be there.
Thank you, sir. Which instrument is used for drying? I guess for canals.
The thing is that generally we tend to use paper points for drying the root canals, but I have shown you a suction tip right now, which is narrow enough to enter inside the root canal and dry it. Drying itself is a different topic altogether, because see, the earlier days when we were trying to introduce AH plus, and we were trying to introduce ZOE into the root canals. Now we are using tricalcium silicate based sealers. Like I told you that you should always read the manufacturer's instructions. When you're using tricalcium silicate based sealers, you may not even want your root canals to be completely dry. You may want it to be very mildly moist, because the moisture from the canal is necessary for your tricalcium silicate based sealer to set. There has been documented data when pre-mixed tricalcium silicate based sealer has found to be setting as late as 1 month after the obturation. So depending on what type of a sealer, you need to decide what type of drying you want to do. If you want complete drying, maybe a paper point is the way to go. If you want mild drying, maybe a suction tip like this could be an option to consider.
Thank you, sir. This you've already answered. Which good tip is used for irrigation and retrieval?
Like I said, of the 3 tips that we have discussed here today, the one that I would suggest is the CU3. The CU3 is the thinnest one. Even the CU1 in the cold tin activator kit is also quite good. So these are kits that I can tell you because I have used them. We have sufficient clinical experience with them, and if we personally vouch for something, we will only vouch for something that we have clinical experience with. So these are 3 that I would feel very comfortable working with. And of all the cases that we have shown here today, all of them have been done with these instruments. So the thinner one would be better, but sometimes if the canal is very big and the indication is different, we can use a slightly thicker one. The CU1 and the CU3, I think, are the ones in case you want to use it for retrievals.
Thank you, sir. Next question. Any tips to avoid ledge formation during ultrasonic activation?
Yeah, the thing is, you should use a narrow tip. Don't use a larger tip. If you use a very narrow tip, the chances of you creating a ledge will be lesser. But some amount of ledge formation may still end up happening, especially when you use a trephine, etc. But see, a ledge is only a problem when the canal beyond the ledge is very narrow, in which case you may find it difficult to manage. So in an uninstrumented canal, when we create a ledge, it is a problem. Now when you have a fractured instrument, it's a different scenario, and you create that is when you'll use an ultrasonic and create a ledge. If you create it, if you retrieve the fractured instrument, the diameter of the fractured instrument has already been instrumented. So the canal beyond the ledge is patent. So what you should do, you should then use the patency, and you should make sure you are able to bypass the ledge, go beyond the ledge with your file, whether rotary or hand, which is relatively easy to do. And you should use anti-curvature filing against the ledge and low amplitude filing, what I told you earlier. Once you have bypassed that area, you should use low amplitude filing. Don't remove the file till you are able to iron out the ledge. So once you do this, it's relatively easy for you to proceed. So it depends on where, what I, more, we have never encountered a problem where we have struggled with the ledge after creating a staging platform or retrieving an instrument. We have never encountered a problem with a ledge. So sometimes, of course, we tend to instrument mildly in the wrong direction. That does tend to happen in heavily curved canals, but we are able to handle that at the time of obturation. We will use a tricalcium silicate based sealer, and we make sure that we get a nice obturation of the whole root canal space, a good 3D obturation. So we are basically treating that extension as potentially not a perforation, just a mild, maybe a gouging of the canal. You can always obturate it with those sealers. So that it pretty much takes care of that also.
Thank you, sir. And again by Dr. Salim, which cross section of the rotary file is better in comparison to the wave one rolled reciprocating file?
That I'm really not sure how I can answer it, because I don't have that much data on the other files. So I will only be able to answer. Maybe I will look into the Wave 1 Gold at some time and I will see, because I have no experience with it at all. Especially the cross
Sure,
section.
sir.
But if you look at the alloy, I can tell you, because alloys, I have a lot of data on alloys. Wave 1 Gold is made with the gold alloy when we do heat treatment. So like I told you, between the blue alloy and the gold alloy, in the heat treatment, the gold precipitate which settles on it. And as per the articles that we have referred thus far, the EDM is significantly better than the Wave 1 when it comes to cyclic fatigue resistance values in the research that we have encountered. But then of course, there could be an alternative opinion also, but I will have to look into it. But what we researched for this presentation, I feel that we are comfortable sharing the information that EDM is better in terms of cyclic fatigue values. Cross sections, I'm not really sure about the Wave 1 cross section, so I'll have to look into it.
Thank you, sir. Rotary instruments can be reused in how many canals in our daily practice?
That's right. That is a fairly difficult question, but if you look at the first part of today's presentation, I told you about number of cycles to failure. So I think it's going to basically come down to that. In fact, we are doing some interesting work on it right now. We'll see where we get to it, and maybe regarding that, I'll be able to answer with some personal experience in the future. Okay, but otherwise, said and done, I feel like I told you in this presentation, the major factor over here in instrument fractures in terms of usage till failure, we should avoid it. Don't try usage till failure. You try to find it, because the usage till failure is just because we are able to average our cost of use of instrument. So I suggest you try to make sure that you feel a reasonable return on investment, if you want to call it that. You get it from your instrument. I want to use this instrument so many times that I am able to get whatever I have spent on it, if you want to put it that way, which is a very crude way of putting it, I know. But if you are able to achieve it at that point in time, dispose it off. Also use methods which I told you, like if you use it in a single canal, which is straight, if you use it in a mildly curved canal, if you use it in a severely curved canals, rate the number of uses differently and accordingly change the number of times you're going to be using the file. If you use it on, say, 3 severely curved canals, I would suggest dispose of the instrument. Don't look at teeth, look at canals. You dispose of that instrument. If you used it in straight canals, maybe you can go up to 8 straight canals. I am not telling this out of my personal experience, not evidence based at all. It is based on the number of leaves in that stopper that I use. So maybe that, with that approach, we have not gone wrong. But whenever you use that approach, please make sure that your assistants know that you're using the stoppers, and those stoppers are not removed off at the time that it's going in for autoclaving. That is something that you have to be very careful, you have to follow up on it. or use any other method that you can use for tracking your instrument usage. There are many ways that innovatively we manage and we're able to track the number of times we use the instruments. But when you track it, also track the type of canals you're using it in.
Thank you, sir. This we've already covered. One doctor has asked, since how many years are you using Coltine ultrasonic tips?
The Coltine ultrasonic I have been using, to be honest, I have been using the Biosonic for quite some time, the earlier Coltine ultrasonic unit, for quite some time. I cannot remember, ever since it came out, we were using it in our practice. This particular ultrasonic tip, I think at the time of their country release itself, before it hit the markets, they were kind enough to share it with me. Correct, Dr. Sneha?
Yes, sir. Yes, sir.
Yeah, so you will be in a
Yes,
better
sir.
position to tell from how long I have been using it. I do not remember because my short-term memory is very poor. Long-term is good, short-term is poor.
Yeah, almost, sir. It's been a year, like almost 8 to
Before I
10
came for
months
that
at least.
Anthony Ketonis workshop in Bombay, a month or
Yes,
two
yes,
before
yes.
that,
So
I don't know
probably
when that.
last November, sir. Last November or December
Yeah. Since then, I've been
last
using
year.
it, and I just love the
Yes.
instrument.
Yes, sir. Yes, sir. Okay. So, can we bypass a broken file with K file only, or we can proceed with 12 3% NiTi rotary file to bypass the canal?
It is completely K-file initially and stainless steel K-file. Don't try using rotary because rotary has got a mind of its own which you cannot control. And start with maybe a 8 or a 10 number K-file. You will go through a lot of K files. You'll have to keep a bucket in your clinic and you'll see the number of K files that we go through. See, the thing is, it's a very, what do you say, unusual thought process that we'll end up developing over a period of time. Whenever you fracture a file, you will spend a lot of time trying to correct that error. And you will realize the amount of time spent trying to correct that error, time is money in a private practice. So you'll realize it is better to spend money on better files than waste your time trying to recover fractured files or have failures and loss of reputation because of fractured files. So that thought process over a period of time will evolve in our respective minds. So when you're using it for retrieval, it will always be a K file. It will, the first 4, 5, 6, 8 number, 10 number files will come out all mangled and deformed. Sometimes they will also fracture and you have to remove them also. So it's a bit of a struggle, but don't go in with rotary. Please go in with K files.
Okay, sir. Can we use HyFlex remover in mesolingual canal? Question by Dr. Shiv Kumar.
No, that's what. There is no indication as per of canals or anything for high flex remover. You can pretty much use high flex remover anywhere as long as you're trying to remove guttapercha because that is the reason for the usage of that particular file. So we use high flex removers in our practice for guttapercha removal. And how has it helped us? We no longer use solvents much. I don't say we don't use it at all, but ever since I started using Remor, again from the time that they've introduced it into the market, we've conducted webinars as well as workshops on retreatment also using the HyFlex Remor, and we have found over a period of time that the need for solvent. Earlier we used to use xylene as a solvent with the K files, very slow process. That requirement has reduced a lot. So we use HyFlex Remor primarily for retrieval of guttapercha. It does not matter which canal it is in. We use it in all the canals wherever guttapercha is present.
Thank you, sir. Does unwinding of a rotary file be considered as to have more chances of cyclic fatigue?
Definitely, but with these martensitic files, that is one of the things that the file does do. It does tend to unwind, and then when you autoclave it, it gets back its original form. And this is the method that we know that the file still has got some life left in it. Now, the cyclic fatigue is going to happen in curved canals, not in straight canals. It will happen in curved canals. And some amount of deformation of the file will tend to happen when you use it. So, those two things are facts of life. We cannot escape it. How well does the file manage to survive? That is dependent on the metallurgy, what we discussed today.
Sure, sir. Sir, can you let us know about the box which has a count of usage of files?
I know. That was
That the
actually
ones were
I,
the
that
one
was
which is
given to me by a dealer in a workshop. I can't recollect
Acha.
who, because sometimes we go to these conferences. I found it to be very interesting. I had a picture. I only have two boxes. I'm trying to figure out who it is. Let me see. If you can message me later in a day or two, I will try
Yeah.
to find it and I will try to share it. Either me or I'll tell to share to Dr. Sneha, and maybe you can collect
Yeah,
it
yeah,
from
sir.
me.
You can post it on the group only, sir, with the
Yeah, yeah. We have a WhatsApp group, Roxana. Let them
photo
ask,
and
and
the name.
I will look it up. I'll definitely look it up and find out. I don't remember. I just it was lying in my clinic.
Thank
That's why I took a photo yesterday and put it into this presentation. I thought it can be useful for somebody. Let them use it.
Yes, sir. Yes, sir. Thank you so much. Uh, Next question is by Dr. Ashar. Which brand suction tip do you use inside the canal?
The only one I personally have seen is the Coltine endo tip. I have not seen any other tip which can be used inside the canal. So, my personal experience, that is the only one that I have seen. And like I said, I'm a huge fan of that particular suction tip. Okay, including the surgery suction tip also, I really like it. There was surgical suction tip, Coltine, which you can change the size.
Yeah.
It comes in three different or two different sizes. So it's a lovely thing. So we do not do any surgical case without that tip. And for our endo, for specific reasons, we keep this particular one. And that method that I showed you, that is something which I have figured out, on my own. I thought I'll share it with you in the video. But I don't know anybody else who has got this. And plus, I can very sincerely vouch
Thank you,
for you
sir.
that the process of making it, I have seen it. I have seen the manufacture and the packing facility where it is done. It is truly amazing. Truly amazing. It's a high quality device. It
Yeah.
is worth that you pay for it. So please go ahead and please approach Colty and ask them to supply to you.
Endosurgery tips, sir. I'll post it on the group, the
Absolutely, absolutely.
brochure for the same.
Just go
Yeah.
for it. Yeah, just go for it. Remember, Sneha, even last time
Yes, sir.
during the workshop, retreatment workshop, I told you please share that endosuction tip. It is one of those things, for
Yes,
people who are really particular, like if they
yes,
really
yes.
want to do really high quality work. These are small things that you need to have with you in your They supply it also so nicely, and it's packed up in a strip. You get like 5, 10 of them. How many of you want to buy? You want to buy a whole box, you
Yeah.
can. And it's nicely sealed. It's gamma irradiated, and it is sealed and given to you. You don't need to worry. When you want it, you tear it and you take it out, single use, and dispose it once you're done. It's not like a generic suction tips which you get in on box. Everything is open. These are all sterile, so you can very comfortably use it with all infection control procedures taken care of inside the root canal. So I don't know if anybody else goes through that length of care to deliver a suction tip to you. So this is the only one that I would recommend.
Yes, sir. Yes, sir. Thank you so much. Are you using bioceramic sealer now for all your cases, sir?
See, I have a lecture which goes on for 2 hours on sealers. It's very similar to this lecture. To put it in a nutshell, in a single sentence, not for all my cases, but I do use bioceramic sealers as part of the option that I would use in my cases. I use all sealers in my cases. Where it is required, which is the most ideal sealer, I try to use that one. But each sealer has got its own pluses and minuses. It's the whole big classification of sealers. A big. Anytime that people from Coltrane want, I can give you a lecture on sealers also. It's very happy to do it. But you have zinc oxygenol based sealers, glass enamel based sealers, silicon based sealers, which is your Coltrane is the only company in the world that makes silicon based sealers. They make Gutaflow 2, Gutaflow BC, and you have methacrylate resin based sealers, you have resin based sealers, you have tricalcium silicate based sealers, you have salicylate based sealers. So there are so many different sealers. Under these 7 classifications, you have tricalcium silicate based sealers. So I feel that you should never use, in our field, in dentistry, you should not do one size fits all. You should, like your files, you should keep all options available. Two, three options should be available. Even if you're buying on cost, buy the high end one, buy the mid range one, buy the low end one, whatever you want to. But always buy the high end one first, because that will set the benchmark for you. Tomorrow, go out there, buy one HighFlex CM, buy a HighFlex EDM, buy one packet and just see how it works for you. Minute you start working with it, then you can benchmark the others. The same way your sealers, try and see which sealer you want to use. There's so many things. I've used so many different sealers, but based on the consistency, based on the wettability, based on what they bring onto the table, based on the evidence that I have read regarding them. Like there was a time I used to use a lot of calcium hydroxide based sealers. Then I read literature that these calcium hydroxide based sealers tend to disappear from the root canal over a period of time, because the calcium hydroxide tends to break down into calcium hydroxide. We changed. So, ZOA is like the go-to from many, many years. But then, of course, tricalcium silicate came in, and then we found this really lovely new sealer available, good wettability, good flow. You can obturate using single cone techniques using it, because you don't require the GP at all, like other than for retreatment purposes. So it is a sealer that I definitely use. I would vouch for it for sure. Bring so much onto the table, but that is not the only sealer we use. We use a number of different sealers also.
Thank you, sir. Okay. Can you explain the return of investment for spending 40 to 75,000 in buying BTR pen or Terauchi file retrieval kit?
Yes, there are some instruments which are a little bit expensive. There is no doubt about it. But see, return on investment is, you will have, even on practice management itself, I have a lovely talk, and it is a talk on how to buy instruments also. So I always feel in your practice you will have various kinds of instruments. You will have instruments that you're going to be using all the time, and your instruments that you're going to be using a few times. But those few times that you use it, it will save your life. So it is going to be there in your kit. So depending on what is your core area of expertise, like for me, I'm an endodontist, and my core area of expertise is endodontics. So in the field of endodontics, I feel that whatever type of case which is there, I should be able to handle. So I keep the full range of endodontic instruments what I require. Then, of course, if you are very genuinely interested in endodontics, you like the craft of endodontics, you feel that your endodontic skills are very highly evolved, and the very fact that you're attending this program on a Sunday morning and listening to this lecture for 2 hours, it means that you want to level up, like what Colteen says, upgrade dentistry. You want to upgrade. So when you want to upgrade, there are certain things which you need to spend. It's like asking for the value of money of a new iPhone. I think the latest iPhone is like 2 lakh rupees, but people are still buying it. So you need to know, are you an early adopter or not? I am a bit of an early adopter, so I usually tend to have all new instruments. Some of them work, some of them don't work. I know the benefits of the loop and I know the failures of a loop. Not, like it doesn't work in all cases, but at least I can give you people a fairly good viewpoint on, whether it is useful or not. And many times for us, at least in our practice, we tend to get a lot of referrals. We get referrals of retreatment cases and file retrieval cases, etc. We are able to handle those referrals in a very honest manner because we have pretty much the whole kit available with us. So with that in mind, if you want to position yourself as somebody who is able to solve most of the situations, you will not be able to solve it if you don't have all the tools available with you. So I'm sure that we have discussed so many things today, but there are many tools over here which are almost, so with each tool, you can level up to a particular point. And beyond that point, you'll not be able to progress because you do not have that particular tool. So that return on investment is, it's a very, I don't think you can bill and recover it. You may be able to if you have that sort of volume, which sometimes we are able to have, but you should not look at it from that point of view. You should look at it from the point of view of being able to offer the solution. So the non-tangible benefit or the non-tangible profit that you can make is very, very high sometimes with these unique instruments.
Thank you, sir. Do all NiTi rotary files have the same composition or differ according to manufacturers?
Yeah, the alloy, I think it does tend to vary as per the exact composition of the NiTi. Again, regarding specific composition, manufacturer to manufacturer, I have not gone through, so I will not be able to answer it. Regarding heat treatments, I know for sure that there is a difference. I'm assuming that the basic alloy may not be too different from manufacturer to manufacturer. But the minute you start doing the heat treatment procedure, the way the alloy behaves is going to be different. So I'm that, but that is just a very long assumption. I will have to look into it to answer you really better or accurately.
Thank you, sir. Dr. Shesh Narayana has asked, please explain inner wall and outer wall of root canal.
This is the inner wall of the curvature and outer wall of the curvature. When you see a curved canal, you will see the inner part, like if you say, take a molar. In the molar, the inner part will be near the furcation, the outer part will be on the mesial wall or the distal wall. So that is the part where if you're working on a fractured file, the inner part, the inner curvature is where if especially if the instrument is at the level of the curvature or beyond the curvature, that is the part that you need to work on to improve your visibility and to loosen the instrument. So that part is, we call it the inner wall. But the instrument is longer than 3 millimeters. If it is 4.6 millimeters, 5.7 millimeters or above that, then sometimes you need to work on the outer wall also, because that file will be leaning on the outer wall of the curvature.
Sir, how about Hanudent files in RCT?
I'm not really sure because I'm not aware of them, to be honest. I'm not sure.
Okay, sir. Sir, please suggest new rotary file system to use step by step.
So we are in a Coltil webinar, so I will suggest Coltil Hyflex CM and Coltil Hyflex EDM. No, but the humor apart, these are the files that I am using and they're really lovely. There's no doubt about it. So it is pretty much the file that I would suggest right now. And if you look at the data also, the EDM file is right up there. But the CM and EDM, they both are made out of the same alloy, except the EDM, the CM is ground, whereas the EDM is through that whatever, electric discharge machining. But both are really, really very good. So please use them and just make your own, form your own opinions about it. But this is the one that I would suggest. Plus, there's a very nice kit that Coltin has come out recently to improve your workflows. It's called as OGSF. I will just request Dr. Sneha to share that details of OGSF on this group. So you'll get a fairly good idea that there are 4 files over here which will make your sequence very easy. One is an orifice shaper, one is a glide path, one is a shaper, one is a finisher file. So I'm sure that she will share that with you. You have a look at that. That will make things a little easier for you.
Sure, sir. Yes, sir. Yes, sir. Why some file systems are providing 3 files in a pack and some 4 to 5?
No, that is the thing. What I told you, the initial file systems used to have 10 files in the file systems. Then we have file systems which actually even say they use one file. But even if you see the file systems which say that with one file, single file rotary systems, even they tend to give you 2 files, one for the narrow canals and one for the wider canals. But I personally am not a big fan of that. I feel better don't look at it from the file system, look at it that the way you want to instrument and type of canal. If it's a straight canal, you can instrument it a particular way. If it is a severely curved canal, I would prefer to reduce the number of curvatures and go in. So I would want 2-3 different tapers working on the coronal third, middle third and the apical third. So, I don't usually go based on what the company gives in the packets. We tend to buy more refills and use the tapers and the size. Like I said, that itself is a whole different discussion on instrumenting root canals, instrumenting curved canals, etc. But the take-home message is that it's better that you select it based on the diameter or the taper that you are comfortable with. So the company, what it does is it just makes a sequence based on the discussions that they have, and so that it's easy for you. So it is good for an entry-level practitioner to know that, okay, I can use 1, 2, 3 and my work will be done. But over a period of time, once you develop experience with it, you will know that in that 1, 2, 3 which you have been given, you may not require 1 most of the time. You may require only 2 and 3. That's a choice that you can make, because that is the mechanical part of the procedure. So the kit is what the company does as a default setting, and they give it to you. But you can always improvise and mix and match. You need not stick to that sequence.
If a fractured file is in the apical 1/3 after obturation, how long should we wait before placing the crown?
No, there's no real guideline for that. The guideline would be more along the lines of what you have decided beforehand itself. See, the decision on putting the crown could be two parts. One, once you put the crown, the tooth is in function, so obviously the patient can feel it. So the success or failure symptomatically will be immediately revealed at that point in time. Number two, the minute you give a crown, the cost committed towards that treatment is higher. So from a clinician's mindset, the clinician thinks now that, oh, if it fails, I have to recover the cost of crown, etc., etc., etc. That both of those lines of thought are not ideally the lines of thought. Theoretically, the line of thought is what we discussed today. You need to see, is there a periapical lesion or not. If there's a periapical lesion present over there, you need to know this case potentially is going to fail. You need to do whatever we discussed today to handle it. Now, if you're unable to retrieve it for whatever reason, then you might as well just go ahead and give the crown and see what happens. Because if it fails, you can at least deal with it quicker, sooner than later. This is my take on it. But then again, it just depends on a lot of things, lot of factors. Some factors will be determined in the clinic itself. So, but I can only tell you the right way of doing it. I think this would be the right way.
So much, sir. Sir, we are almost done with the questions. One question is, when can we use EDTA liquid?
Yeah. So the thing is, the question of which liquid to use. Now that discussion has been taken forward by Yoshi Tarochi himself. So he has said there are two things. There's something called as surface tension and something called as viscosity. Viscosity and surface tension are things you need to understand. Water has got low viscosity, but it has got high surface tension. When you put it on a surface, you see it forms a nice bubble. That is high surface tension, but it has got low viscosity. Whereas, syrup has got high viscosity and it has got high surface tension. It is a high viscosity, high surface tension solution. What do we want to use? Yoshi Tarochi has suggested the use of soybean oil. Why? Because it has got medium viscosity. So unlike water, it is not low viscosity. You require some viscosity without which you will not have good acoustic streaming and cavitation. Of course, you need to increase the power of your ultrasonic to get that effect happening, but you need some viscosity. So medium viscosity is suitable. And you require low surface tension because the liquid has to flow. Water has got high surface tension. So ideally you require low surface tension. So soybean oil has been suggested because it has got low surface tension and medium viscosity. Now EDTA has got a low viscosity and it has got low surface tension. So if you compare, it looks like water, but it has got low viscosity and it has got low surface tension. So because of the low surface tension, it is a good solution to use. So you can use EDTA or soybean oil. But again, according to evidence, you can't use both in all cases. In straighter canals, it is suggested use EDTA. In curved canals, it is suggested use soybean oil because you can generate more acoustic streaming with soybean oil, and with soybean oil the instrument does not come out faster, it comes out very slowly. So because of that, it is suggested that it is used in curved canals only. In straight canals, EDTA is the recommended liquid for lubrication.
Thank you, sir. One question, sir, during endo treatment of a teeth with no periapical radiolucency, file fractured after irrigation on the end stage, 2.5 millimeters short of the apex. I obturated after that and recalled the patient for review. IOPA 6 and 12 months. No changes till now and asymptomatic. Shall I give crown to the patient?
Yeah, you can go ahead. You can go ahead. Like I said, like what we discussed today, if there's no periapical lesion, so that is one thing that you have checked. So that is probably a good thing. You have said instrumentation is completed, which is excellent. And finally, you have done a 1 year follow up. So the 1 year follow up is also something which is very important. So normally, if you look at follow up itself, in cases we have like what is the protocol for follow up in endodontics, there is a particular method which has been suggested. I think it's by Ostrovik. So in that method, 1 year is the point where we decide we don't require any further follow up. This is following us taking a radiograph at the end of 1 year, ensuring that the lesion has completely resolved, after which the truth is also asymptomatic. If both things are there, you don't need any more follow up. But if the lesion has become smaller, it has not completely disappeared, it has become smaller, then do one more follow up at the end of 2 years. If the lesion has become bigger, patient is asymptomatic, but the lesion has become bigger, better to retreat. This is the general guideline for follow ups. So, if you, what you're telling, I'm assuming you've done 1 year follow up, there is no lesion, patient is asymptomatic, you can consider the treatment as successful as of right now, as per the data, you know, how we are supposed to examine follow ups, because they say that there is no healing reversal in endodontics. Once the healing starts, as long as the core buildup is done, it is successful, you don't need to worry about it at all. So, according to this, you can go and you can give the crown, you can complete your case.
Sure, sir. So, sir, we are almost completed with the questions. A few are repeat questions only, which we have already covered. So, if there are any more questions, we can take it up on the group itself. So,
Perfect.
thank you again so much, sir, for this wonderful session. And it was really very, very informative. The demonstration part, the presentation was really very informative and engaging. The participants have really loved the session, and there are very good reviews on the group as well, sir. So if there are any more questions, doctors, you can keep asking them on this group. Sir is also there on the WhatsApp group. Also, we'll be shortly sharing the details for the FlexCPM OGSF sequence, as well as the endosurgery and the activator. And if there are any more questions or doubts which you have, you can definitely connect with sir anytime. He will be there to answer those questions. So thank you once again, sir. Thank you once again, Sanjay sir, Shashi sir, for all the help.
Thanks everyone. Okay, thank you Sanjay and Shashi for being here all morning. Thank you, thank you, thank you. It was wonderful. You and I had a lovely time. So I thank all the participants also for being here. It's a Sunday morning, now we're into afternoon. So we had a lovely, lovely discussion. Like Dr. Sneha said, we'll continue the discussion on the WhatsApp group. Any queries you have, please post it over there. And as time will allow it, I will sincerely try to reply back to you. Okay? Thank you. Thank you.
Sure, sir, sure. Thank you. Thank you so much again. And thank you for all the participants for the wonderful attendance and appreciation for sirs. Thank you so much, sir, once again. Have a nice
you.
day, everyone. And the recording would be shared shortly. Thank you so much, Sanjay sir and Shashi sir. Thank you so much, Dr. Darshana. Thank you again, sir.